Hello. Mm, We will start. We'll wait for the moment. Good afternoon, everyone. We will start this sessions within a few minutes. Thank you. Good afternoon, sir. Good afternoon, and we welcome from our organizing committee. So, can we start, sir, within a couple of minutes?
Good.
Am I audible, sir? Professor Eric, sir?
Yeah, you can hear me?
Okay, sir. So,
Good.
within a couple of minutes, we will start, sir, because the participant is very late here. So, we may wait for 2 minutes, 2 or 3 minutes.
Okay, good. Should I have the video on or not?
Your video is not on, sir.
Okay.
Now it's turned on, sir. Good morning, Dr. Akhilesh, sir. Welcome you, sir, as a panelist of this session.
Just a second, guys. Let me find out. Hi, Eric.
Hello.
Hi. Sorry, I'm not in the pink of my health today. I dropped an email. Uh, just some viral. But I'm looking forward to your session, Eric. After that, I'm talking about strategic capacity management in remanufacturing. So, looking forward to your presentation. Good to see. I'm one of the alumni of this institute. Currently, I'm at Indian Institute of Management, Raipur. I worked at Indian Institute of Technology, Kharagpur earlier. Nice to meet you.
Yeah.
It's also good to see you, sir.
Thank you. Right?
So, sir, we have already. Yes, sir. Please, sir. Okay. So already we have a sufficient candidates, sir. So we may start. So once again, I welcome and good afternoon to our honorable speaker, Professor Eric Salin, sir. And also I welcome to our panelists and all the participants of this sessions. I'm Dr. Jageshwar Verma, coordinating these sessions on behalf of our organizing committee. And this workshop actually jointly organized by the National Institute of Advanced Manufacturing Technology, NIMT, and the Futuristic and Advanced Manufacturing Forum of India. Before over to the sessions to the honorable speaker, Professor Eric, sir, it's my indeed privilege to introduce a noted eminent researcher, Professor Eric, sir, from Linköping University, Sweden. As the speaker of the sessions on circularity of sustainability, such topic is the role of remanufacturing and sustainable economic growth in India. Sir did his postgraduate MSc in applied physics and electrical engineering from Linköping University in 1998. Sir has completed his PhD from Linköping University, Sweden in 2004 in assembly technology. The title was Product and Process Design for Successful Remanufacturing. His PhD dissertations has been downloaded more than 16,000 times from the university electronical library, which makes it one of the 20 most popular dissertations from the Linköping University. It's very great achievement, sir, and we also congratulate you, sir, for this. His research has been focusing on remanufacturing, but recently areas of sustainable manufacturing and the product service system also have been a part of his research. According to publication analysis made by leading researcher within sustainability, Professor Erickson is a top researchers, 8th in the world. When it comes to publishing research paper about product service system, once again, sir, congratulations. He has worked within several European Union projects called CN Reman, ERN, Circuit and L4 ideas. Both CN Reman and the European Remanufacturing Network are aiming at improving the business and operations of European manufacturing companies, including example, the local companies of Toyota, Materials Handling, and Siemens Industrial Turbo Machinery. Sir is the author of more or less 30 high-impact journal papers, 81 international conference papers, 8 books chapters, and 6 popular science articles. Sir has several scientific collaboration with Simtech Singapore, Springer Verlag as a regional editor, and the International PSS Design Research Community. Sir has been awarded Emerald Literary Network 210 for excellence for the paper, product design for product service system, and best paper award for the paper exploring the use of product life cycle information in 2 value chains, including remanufacturing. It's our proud privilege to have him today as a speaker of these sessions on role of remanufacturing in sustainable economic growth in India. So thank you, sir, for your vital appearance in these sessions. Now I over to these sessions to you, sir. So please.
Okay, thank you very much for that introduction. So I will share my screen here. So thank you very much for having me doing this presentation for you guys. Let's see if it works. There it goes. So my name is Erik Sundin, Professor of Sustainable Manufacturing, and you had a lot of my background in the introduction, but I mainly do research within remanufacturing. I've been doing this since I started in 1999 as a PhD student. And remanufacturing is a part of circular economy, and circular economy is a hot topic now in Europe. And you can see here, this is the famous butterfly diagram showing what circular economy is from the Ellen MacArthur Foundation. And looking here on the right-hand side, you can see you have parts manufacturers that produce, and then you produce products, and then you provide services, and they are used. They can be shared, reused, refurbished, or remanufactured and recycled. So it's about getting the loops back and getting the stuff going around several times. So you see remanufacturing is one of these strategies. So there's a place in circular economy. And why is it done this focus on circularity? Well, there are, for example, new standards in this area. For example, the British Standard on Circular Economy, it came 2017. And there's also this CEN/SELENAC standards in electronic products for material efficiency. And also now we're working on first an ISO standard on circular economy, defining what it is. Furthermore, there are these circular trends in Europe, for example, that you have this right to repair in France, and new EU directives about material efficiency, new public procurement laws trying to have lower footprints. And also it's been easier now to sell stuff on eBay and through social media. And it's quite profitable aftermarket in many of these business sectors, and there's also a growing awareness about reuse and remanufacturing. So these are reasons why circularity is in focus now. So what is then remanufacturing? Maybe you will see some different kind of definitions, but this is what we have been working on in remanufacturing research, that it is an industrial process to rebuild a product, and the parts are then cleaned, inspected, and disassembled. Some components are replaced, and then the product is reassembled and tested and inspected again to ensure it meets or exceeds newly manufactured standards. And then what gets into this process are called cores, and that is used and broken down products or components aimed for remanufacturing. So you see some examples here, and it could be like an entire product, like a computer or a photocopier or furniture, but it can also be a part of a product like an engine or a tuner cartridge, for example. And further on standardization work, there's this newly launched American national standard called Specifications for the Process of Remanufacturing. And here, the whole standard is about remanufacturing, and they define remanufacturing as a comprehensive and rigorous industrial process by which a previously sold or leased, used, worn, remanufactured or non-functional product or part is returned to like new, same as when new, or better than when new condition, from both a quality and performance perspective through a controlled, reproducible, and sustainable process. And this was an update of a previous standard, and this was established now in December 2021. And the reason why they have this standard in the US is that they have many remanufacturing companies there, and they, when having this standard, they can point at this standard saying, okay, we're doing remanufacturing according to this standard. So if they have customers asking them what does it mean that you do remanufacturing, they can point to this standard, and they can also have a stamp according to this standard saying that they do remanufacturing according to this. But also they have many YouTube videos where showing what's happening in their exact process. So in research, we use terms like remanufacturing and core, as I mentioned, and remanufacturing facility. So here you can see me and my colleagues from Linköping. But if you go to industry, they could call it different things, and that makes it sometimes hard to find them as a researcher or as a customer. So for example, if we talk to Toyota Material Handling, they say that they do refurbishment of their used forklift trucks, and they do this in facilities that they call fleet management centers. But if we talk with Tetra Pak, they would call it renovation of their second-hand equipment, and they do this in renovation centers. And this is quite interesting. Tetra Pak, that they started doing this remanufacturing a few years back because they wanted to protect their brand, and having other doing repairs of the products on the market, and maybe they were not in the control of Tetra Pak, and if the repair was not that good, then they still get a bad rumor because it has the Tetra Pak brand on it. So they wanted to control it, and then they start doing it. And I think they are quite successful, especially in India. Further on, why do companies do remanufacturing? This we have been asking companies, and also we've been reading literature about this topic. And companies are existing mainly because they are making profit. They do this to reduce costs because it's cheaper to do remanufacturing than having new manufacturing. It could also be from a customer needs perspective. The customer wants to buy remanufactured products. It could also be that you want to provide spare parts to the market that are remanufactured. It could also be that you want to target a new market segment with reman products. So if you have a high-end product and then you remanufactured it, and then you are competing then with maybe lower brands with the same price range. And it could also be that you do this as a part of a new business model. For example, if you sell your products as a service, which I will exemplify here. This could be that you sell the function of a product rather than the product itself. For example, selling the number of copies instead of a photocopier. This is quite common that we have, for example, in our university here, we don't buy the photocopiers. We have the service, and then we pay for the copies. We don't even have staff, or we don't fill it up with paper. There's someone else doing that. It's a part of the agreement. And it could also be for aircrafts that you sell the number of flight hours instead of an aircraft engine. And also looking at research on this topic is that you sell not the product, a pure product based on value based on product, and not a pure service where value is based on service. Somewhere in between this product service system, it could be product oriented, use oriented, result oriented, for example. And in general, I would say in research we would call this product service systems, but a common term used in industry is this product as a service. And this is also a trend in several industrial sectors. So it means then changes in the product and component flows. So having this example of producing electric vehicles, for example, you have these components, batteries and tires and chassis that you put together into cars in classical car manufacturing. You sell it traditionally, and you have a happy customer. And then after a certain time and mileage, they go to car dismantlers. But there's a trend quite much also here in Sweden that you lease, you private lease the cars instead. So this means that you don't need to produce so many new vehicles, and you have the product, the car sold as a service, but then you have to do several checkups, preventive maintenance, and then the customer knows exactly what they pay for, and there's no cost for repairs or no worries about how good are the batteries when we want to sell this further. And then less cars goes to scrapping, car dismantling after, but they go there, but after a quite long time. So then this trend also then put new requirements on the system. For example, the new design requirements would mean that the cars and the parts need to be more robust and more easy to repair and more easy to remanufacture. And the business is also changing then, that you have to be able to do this smart condition monitoring, more preventive maintenance, and you have a closer customer relation. You meet the customer more often. And if you do a good job for the customer, then it's more likely that the customer will come back to you for the same service. And as a user, you have more predictive costs, a higher customer satisfaction, hopefully, and also a higher mileage before scrapping the car. So this is a trend, especially in the automotive area, looking on electric cars in Sweden. Some other examples here, you can see a supplier of product as a service. For example, these forklift trucks where you have Toyota Material Handling, they use the physical equipment of forklift trucks to sell rental plans. And it could also be equipment for constructions like these soil compactors here, where you have a manufacturing company called Svepak. They are selling their physical products to Remanufacturing, for example, a company that provides rental contracts for these soil compactors. And a more recent example is Electrolux. They're manufacturing the robot vacuum cleaners. And here you can pay per square meters and month. So yeah, this is a little bit of Swedish. You can rent it for 79 Swedish krona per month. That's like 8 euros roughly per month. So it's not only in car industry that there's a trend of having products sold as a service. And here is the example of Toyota Material Handling. They are one of the biggest forklift truck manufacturers in the world, but they have this marketing saying that don't buy trucks. It makes sense to use a fleet of trucks to facilitate efficient materials handling, but you don't have to own it to use it. That's interesting because they want people to lease their products instead. So ideally, looking at the physical forklift truck, they would like to sell it on when it's newly manufactured on long-term rental. They would also like to sell it on short-term rental or as used or as scrap with the material value. And to be able to sell the same forklift truck several times, you need to have these fleet management centers where they do the remanufacturing of the forklift trucks. So it's about being able to sell several times, and it does not need to be a new product all the time. So now they have this remanufacturing of forklift trucks in all the sales companies in Europe. In Europe, more than 75% of the forklift trucks are sold on these rental contracts, products as a service. This is not the same figures all around the world, but it works well in Europe. And how is then connected with remanufacturing? Well, if you sell a product as a service, then you reduce the uncertainty of when and how many of these cores that goes to remanufacturing. This is quite common a challenge for remanufacturing companies not knowing. And it also gives better possibilities for condition monitoring that provide data for remanufacturing. And also, if you're an OEM doing remanufacturing, you can use the data knowledge also from remanufacturing to give feedback to the designers, knowing how to design their products better for product as a service or remanufacturing. So having products sold as a service or product service systems and good knowledge about the cores is an approach then to overcome some of the remanufacturing challenges that are currently. Further on, drivers why companies are doing remanufacturing successfully is also to follow directives from the European Union, for example, and legislation, national legislation. It could also be from moral and ethical reasons that you want to be an attractive employer, getting the best economics and engineers because they are proud of working at a sustainable company, perhaps. And here are some examples of European Union directives that goes into the direction of reuse, remanufacturing, recycling. And I would highlight especially this eco-design directive. They have focusing much now on energy efficiency for electric products, but now currently there's also additional new focus on material efficiency that we have also launched these recent standards on, looking at durability, repairs, remanufacturing, recycling, for example. Further on, there could also be drivers for companies doing remanufacturing from a policy perspective. As I mentioned before with the Tetra Pak, they want to protect the aftermarket, protect the brand, and be able to provide additional aftermarket solutions. And in a good world here, you have remanufacturing drivers from different areas here, and it's good. You get this win-win-win situation. It's good for you as a remanufacturing company because you earn money. It's good for the customer who can buy a high quality product to an attractive price. And it's also good for the society because it creates jobs on the market and also good for the environment. Now, I will talk a little bit about one of our quite recent European Union projects that was run between 2015 and 17, called European Remanufacturing Network. And this project we did to enable new business to bring up remanufacturing in Europe, but also helping the ones that are already existing. We did some market studies of some 100 remanufacturing companies, and also we checked the best practices regarding business models, product design, and remanufacturing processes. We had different workshops and also we launched the European Remanufacturing Council, ERC, and we have this website, remanufacturing.eu, that also describes more examples and what remanufacturing is in Europe. And this we did in collaboration with other universities in Europe. So looking at the market study, we checked which industry sectors in Europe that were involved in this remanufacturing, what turnover they had, how many firms, how many they are employing, how many cores they treat, and also looking at the intensity. This is meaning how many products being manufactured in comparison to remanufacturing. As you can see here, the intensity is quite low, around 2% in general. So there's a lot of potential, a lot of cores that could be remanufactured there. Further on, I will explain a little bit about the business model survey that we performed. And the objective was to better understand how remanufacturing companies are doing their business, how they earn money, and what kind of challenges they have, how they receive their cores, looking at economic and environmental perspectives. And we concluded this also done in a business model landscape report, accessible on the internet. And we were targeting this around 100 companies with interviews, mainly in Germany, Holland, UK, and Sweden. And we did this Linköping University together with the University of Strathclyde and a company called Circularity. And after some work, we came up with this 30 company business model descriptions, where we stated down where they were located, what type of remanufacturer they are, how long they have done it, some contact and websites, how they source cores, and how their business model look like, and what environmental and social benefits they have. And these are also available on the remanufacturing.eu webpage. So good for other researchers also to contact this company. And I will bring up some of the results here. And one question was what type of remanufacturer they are. And you can see here that 1/4 roughly were OEMs doing the remanufacturing of their own products. Some of them, another 1/4 roughly, was contracted by the OEMs to do remanufacturing for them. And then most of them, half of the group here that we interviewed, were independent remanufacturers. So these are the remanufacturers collecting cores on the market, doing remanufacturing, and not having so much interaction with the OEM. And quite many of these remanufacturing companies were old, more than 20 years old in the business, and some were a little bit newer. The newer ones were mainly from electronic industry, and the older ones were maybe from automotive business. And here you can see the industrial sectors: automotive, electronics, and machinery. And as we were asking questions about business models, we got through to quite many of those companies that we have collaborated with for some time. So I think that is also one reason why quite many of the companies were old that we were contacting. And then we asked them, how do they retrieve the cores? How do they collect the cores? And this was quite a big mix, as you can see here on this graph, that some of them were ownership based, maybe on these kind of rental contracts. And then there were some service contract based or direct order based, deposit credit based, that you get something back for returning. But quite many of these were then buyback based, that the companies buy them on the market as used products. And there are companies just being core brokers dealing with cores. And then there were also some that were more voluntary based. That could be, for example, for tuner cartridges, that you put out boxes to offices and let them put the used tuner cartridges there voluntarily, and then they are collected. And quite commonly, the companies have different sources to get these products back. So they were not only relying on one source. And then we asked also the companies here, what does your customer value with your remanufacturing offer products? And most of the remanufacturing company customers says that it's a price-worthy option in comparison to new products, because it has a lower price but with the same or better quality. 11 say, and some 5 of them also said that it provides a faster solution, so it goes faster to get hold on a remanufactured product than a new one, if you have long delivery times, for example. And also 5 of the respondents said that it's a good option to discard used products. For example, to tuner cartridges, I think this is valid. And then we also asked them about the price, a little bit sensitive question, but we asked them, okay, how much price reduction do you give to your customers for your remanufactured products? And if you compare with the price of a new product, all the way to the left here in this graph, companies, the figures in here is how many companies they have made the answer. One company said, yeah, we give 10 to 30% discount. Some say 80%, but mostly are around half price. And this is very much market driven. How much are the customers willing to pay? But as you can see here, they give some kind of reduction. The ones that we have answered here. Ask this question, please. And then we asked them about challenges. This is interesting. And some companies say that they have challenges. They agree on that. 8 of them say sometimes it's hard to stay competitive, profitable. Maybe it's too much competition on the market. Some say also that they have problems in getting enough cores or how dealing with the cores. Some say also, 5 of them say that there's a lack of customer awareness, that the customers don't know the benefits of remanufacturing or don't know where to buy these remanufactured products. There could also be some product design issues, that it's really hard to do the remanufacturing. Maybe it's hard to clean or disassemble or something like that. And some also said that they had some problems in having a good efficiency in the remanufacturing process. It could be that you have half finished cores lying around waiting for components to get there. Could take time. Key resources, we asked them also about. What the key resources for these remanufacturing companies is. They mentioned mainly the staff, the technical staff, but also the economic staff, knowing what to do with the cores when they arrive, understanding what needs to be changed, how much time can you put on this, is it possible, do we have a customer for this? Also, there could be a key resource that they have a unique access to the cores, for example, if the products are sold as a service, or they have unique, very good facilities, machinery and equipment. Maybe they have developed their new innovative process for doing cleaning or disassembling, for example. And then one of the guys, an OEM sales manager from ATP, says that core is king. By that, he means that the one who is controlling the cores on the market is then also controlling the remanufacturing business. So the access to cores is quite crucial. And then we asked them also about their environmental benefits. And you see some answer here that is reducing the material consumption, reducing the CO2 emissions, and also the energy consumption. Just some examples. And social benefits is that it creates jobs out on the market. It gives more people access to the products. So companies or people they're not willing to buy a new car or a new iPhone. They are willing to buy maybe a remanufactured one instead. And some companies say that they get these kind of awards. So this was a proud company, ATP. They got the Queen's Award for Enterprise, the innovation category, in remanufacturing. And looking more on why this is sustainable or environmental perspectives of remanufacturing. I know you will have also some other lectures on this during this workshop, but it's that you have less operation steps compared to manufacturing. You don't have any material extraction, no material manufacturing, no component manufacturing, but you do have to collect the cores, disassemble them and clean them and do the whole remanufacturing process. And these have shown, for example, this is from the Automotive Parts Remanufacturing Association in Europe, that they have shown this reduction of material uses, CO2 emissions and energy, for example. And me and a postdoc of mine, Huimian Li from Singapore, we looked on other environmental studies. And some examples here you can see from different authors and different products. And then the environmental results is usually the remanufacturing is better than new manufacturing and recycling. But a little bit depending on what kind of products you study, it becomes more interesting from an environmental perspective. So for example, if you look on diesel engine where you can reuse a lot of stuff, components in remanufacturing, it's a big benefits. It's not that big benefits for electric products, for example. Further on, these were the products that were studied in these environmental studies, like photocopiers, printer cartridges, washing machines, refrigerator, diesel engines, fuel injectors, wireless switches, alternators, and gearboxes. Quite much mechanical industrial products, and some of them were sold as a service, quite high technology sectors, not so much fashion or status related markets. So the ways that we found in these studies that remanufacturing is good for the environment is, in comparison to new manufacturing or recycling, the following: that it has a better use of resources, you reduce the global warming potential, you have a good way of closing the loop for components that contains toxic materials like mercury. So instead of having them lying around in the forest or in ditches, then you get the products back and you can treat toxic materials better. And here are some more reading about remanufacturing, and you have the remanufacturing website. And now I will talk a little bit also on designing for remanufacturing. So when you design products for remanufacturing, then you need to facilitate all these remanufacturing steps. And these are the 7 general steps in a remanufacturing process. You have the cleaning, inspection, storing parts, disassembly, reassemble, reprocessing of parts if it's necessary, testing. So you can do it like this, that you put these remanufacturing steps on one side of a matrix, and then looking at preferable product properties that you want to give your components and your products to be able to facilitate these steps, to make sure that all the steps are passed through in a good and efficient way. And an example here about the soil compactors is the soil compactors designed by Svepack International in Sweden. They have a good understanding of what the customer values are to be able to sell this product as a service and do repairs and remanufacturing. They have adapted the products, as I will show you soon, and also adapted their service organization around it. So what they've done here in this design development, going from left to the right, that they understand in the beginning here, maybe this was 15 years ago, they had this design with a soil compactor that was a lot consisting of a lot of painted steel, and when they do remanufacturing and repairs, they need to do a lot of repainting, and that took a lot of time and was not so cost efficient. So then they changed the hood material, you can see here, to a colored through plastic to make scratches not so visible, and also to make it easier to change the hood. And this you can see also, for example, on laptops like the IBM ThinkPad. It's also good in that perspective. What did they do more? They did this adding a rubber bellow around here, you can see, to avoid unnecessary damage. And they also changed the transport device. This is the device that you use when moving it, the soil compactor, between different construction sites to make it not be easily dropped, safer transport. And also they chose a very good material for the bottom plate. It's made of Hardox steel. And in this version here, you can see that they have taken away the painted steel totally. So they use this material and treatment, surface treatment, that is kind of self-healing material that you have on trailers that you put behind cars. So then they have eliminated the need for repainting totally by doing this design changes. So by doing these design changes, designing for product as a service and remanufacturing, you have less visible damages, less need of repainting, easier change of cover, and less wear out to transport and safer transports. And currently, this company is now also into this big change of design where they try to electrify their products as much as possible, and that's another challenge. But I think it's a good example of how you can work with a design to make it fit circularity and remanufacturing. And here are some other sources and studies for designing for remanufacturing that you can check out later. But now I will open up the floor a little bit for questions. And thank you very much for listening. Do you have any questions?
Thank you very much, sir. Thank you very much, sir, for your enlightening lecture. Definitely, it was a very worthy lecture. I may request to all the participants, if you have queries, you can write in a question answer box, or you can raise your hand to ask the questions to Professor Eric, sir. Yeah, we have one question, sir. You may look over, could I tell, sir?
I can read it.
Okay.
So what are the key challenges for business model of machinery manufacturing in the European Union? And also about consumer reactions for remanufactured products in the EU market. Yeah, I think machinery remanufacturing is a quite good business model in the European Union. I think quite many companies are doing this. I don't think there's any specific challenges with that. But looking at the consumer reactions, I think that is quite interesting. I mean, business to business, people know about this. It's a good thing and they can rely on it. But when it comes to consumer, it's a little bit trickier. And here it's quite important. For example, if you are an OEM, then you can say that these products have been in our care. We have been doing maintenance of it in a good way. They have the kind of right stamp in the service book, I would say. And then they are more reliable. They trust more these remanufactured products if they are remanufactured by the OEM, I would say. And we have been looking, for example, for the remanufacturing of robotic lawn movers for Husqvarna. It's quite trustworthy. All right, so yes, a question here also about self-healing material. Yeah, I think the price difference for using that material is quite higher than doing this, using this painted steel, of course, yes. But in this case, they have done this calculation that it's worthwhile to invest in this more robust material to be able to sell the product so many times, several times. So this is also, as I mentioned, also for the cars and the components, that you have to do the calculation, and in some cases it's better to use more robust materials and robust parts to be able to meet the new customer requirements. Yeah, a good question.
Thank you, sir. I think we have only these two questions. Thank you very much, sir. This time it's my privilege to present the vote of thanks on behalf of our organizing committee. It's organized by this National Institute of Advanced Manufacturing Technology and the FOMFI, the Futuristic Advanced Manufacturing Forum of India. I would like to express our gratitude to Honorable Speaker, who has spared his precious time for us and graced these occasions with his vital appearance. Thank you, sir, for this enlightening presentation and sharing your knowledge on remanufacturing. It's also a very tremendous domain. We have learned from you that why the company do remanufacturing and what the need of remanufacturing, how we can make a turnover on that remanufacturing, and without means we can the cost will be reduced here, but the quality will improve in the remanufacturing. Like this, you have enlightened us with this very fantastic presentation, sir. Thank you very much, sir.
Thank you very much.
Thank you, sir. Now we have another session. We have Dr. Akhilesh sir here. So we will start the second session of this circular sustainability with Dr. Akhilesh sir. So before starting our sessions, before we go to the sessions to Professor Dr. Akhilesh sir, it's my indeed privilege to introduce noted eminent speaker Dr. Akhilesh sir as the speaker of these sessions on smart manufacturing. So sir's today's topic is smart remanufacturing. Sir is currently working as an associate professor at IIM Raipur, that is Chhattisgarh, India. So previously he worked as an associate professor in the Department of Industrial and System Engineering at IIT Kharagpur. He received his BTech degree in the manufacturing engineering from National Institute of Foundry and Force Technology. Now it's National Institute of Advanced Manufacturing Technology. So he did his BTech in 2005. He received his PhD degree in industrial engineering from Wayne State University, USA in the year of 2011. He's basically working in the area of operations and quantitative methods. He has authored several technical papers. His publication appeared in various journals as European Journal of Operational Research, Computers and Industrial Engineering, Annals of Operation Research, International Journal of Production Economics, Expert System with Application, IEEE. He was team lead for IoT in a predictive maintenance project with the Samar Udyog Bharat 4.0, Department of Heavy Industry, Government of India. He has carried out various research and consultancy projects with SAIL, Tata Sons, Tata Metallics, Tata Hitachi, TM International Logistics Limited, DHI, Government of India, European Union, Ford Motor Company, and Delphi Automotive LLP. He is a recipient of Faculty Excellence Award 2020 at IIT Kharagpur. It's our proud privilege to have him today as a speaker of these sessions on smart remanufacturing. Thank you very much, sir. Now I over to the sessions to the Professor Dr. Akhilesh, sir. Sir, please.
Thank you, sir. Let me first share my screen and then we'll start. Is it shared?
Yes, sir.
Can you see it?
Yes,
okay,
sir.
Great presentation, Eric. In fact, my presentation actually built upon what Eric had discussed. What I will be showing today is more of mathematical models that can be developed on what his research actually, the next part of his research. So I will be looking at spare parts capacity planning in closed loop supply chain, circular economy approach. Already about me, it has been discussed. I'm one of the alumni of the NIFT, now NIAMT. And I have been working with various organizations in the past. I worked in industry, I worked in academia, and today I'm here. So I think as far as this introduction is concerned, many of these have been shared. Actually, let me see if I can remove it. Because this is on circular economy, many of these things have already been discussed. Is the couple of sessions which has already happened. As the population is growing, the level of product consumption is becoming higher and higher with the population. But with product consumption, wastage and requirement of new materials are also growing in the same. In fact, you look at the society today, it is mostly governed by take, make, and throw away. So you take the resources, make something, use it, and throw away. And that is actually ending up in the landfills. Some of the examples already given by the Eric, like Xerox is fighting for CE delay to circular economy to deliver economic, social, and environmental benefits. Not even today on, they have been trying this, SaaS kind of services that you lease our product rather than buy it. So they have been into that kind of business for very, very long, especially Cartage's business. All these business have already have seen with many business cases studied that. But I'm looking from a totally different perspective. I will be looking from aftermarket industry. So if you look at the automobiles, white goods, industrial machinery, information technology, the aftermarket almost has become 4 to 5 times larger than the original equipment business itself. In fact, one of the research from Aberdeen Group has suggested that after sales service in the US at 8% of annual GDP. And people actually, the American business and consumers are spending approximately $1 trillion every year on the assets they already own. Some selected examples for gas turbines, helicopter, data storage, and extra other things are shown on the right hand side. You can see selected examples here that gas turbines aftermarket lifetime value is in the 70% of the sales price. As far as passenger cars is 16%. So it's not that aftermarket service is important, but at the same time, laws which Eric mentioned for EU, there are laws which is asking OEMs to provide spare parts after the model is obsolete to some years. Like for automotive products, it goes as long as 10 to 12 years. When it comes to aftermarket supply chain as compared to your forward or manufacturing supply chain, the nature of demand is completely unpredictable. And frankly speaking, in OEM, on an average, carrying 10% of his annual sales as spares. But although they are, carrying all those spares, but demands will arise or not, that is a big question. And many times it will be sold, many times there will be lost opportunities, many times there will be lawsuits. If you have taken your car or in vehicle, you must have faced that 50% of the time there is unnecessary delay because there is no right parts to fix them. So these are the user level, customer level, we face these problems also. Most of the firm OEMs actually looks it as a necessary evil that you have to provide, but we don't want to. Now, as it was in the last presentation also, the third party vendors or the independent remanufacturer or manufacturer have become so price competitive that OEM loses that market. People generally go, if they have a damage in the car, they go to the mom and pop shop or local garage and they try to get it fixed. So this table actually trying to show that nature of demand for manufacturing supply chain versus after sales and service supply chain. If you look at the number of SKU, this is limited in the manufacturing supply chain. It is 15 to 20 times more in case of aftermarket supply chain. So the question becomes, I raised that. I will be focusing only on the excuse me, automotive aftermarket. So if you look at the automotive, in fact, for any aftermarket, the reason I'm taking automotive aftermarket, it can be classified into two: original equipment service, which is generally covered under warranty, that you have a warranty for 3 years or 100,000 miles or whatever it is. Based on that, a warranty is provided to you, and then there is a independent aftermarket. One of the reports says that USD 48.5 billion in 2021 is the aftermarket size. And this is further compounded annual growth with 3.4% from 2022 to 2030. Now, the one good part so far, maybe things will change in future as customer becomes more aware, laws become more stringent. The remanufactured product, I'm directly going to remanufactured product because that could be one viable option to provide aftermarket industry. Remanufactured product does not compete with your original equipment service. So if I have a remanufactured product, I will only do the aftermarket with it. So suppose I have rebuilt or remanufactured an engine, I will only use for it for service, not for making the new cars. So if you look at a typical production life cycle, after business pursuit and product process development, what you see is the original equipment sales happens, and after few months, years, whatever you say, original equipment service starts. As the product goes into market, it faces the field, there are breakdowns, there are damages, it comes to the original equipment, if it is under the warranty, it comes to original equipment services. After few, just a second. After sometimes independent aftermarket starts, because if I sold some 1,000 cars today, for next 3 years or 5 years, they will be under original equipment service, and after that independent aftermarket starts. People sometimes prefer to go to the authorized dealer to get the parts fixed, or they just go to their local garage and or body shop to get things done. Now the issue is OE production is happening in this time frame, but original equipment, and there is a last, what we call last production. What it does, the companies puts some inventory of spare parts at this point and tries to support this planning horizon. Sometimes they also manufacture in this plan, but what happens if they have put a lot of inventory, it may or may not be consumed during the life cycle of aftermarket services. If they have a lot of spare parts, they might be just sitting in their lot, adding up to the inventory cost. If they do not have enough inventory or spare parts inventory, they will end up losing the market share, some lawsuits, everything. So what a probable solution from a circular economy point of view, that let's start doing some kind of remanufacturing. Okay, so if to support the original equipment service and IAM, independent aftermarket, I can think of supporting it with the remanufacturing of production, because what happens, the moment this product fails and comes here, I will have a core, and I'm talking only from the one which is going to dealers. I have a core. I can, again, depending on severity of core, I believe that it can be remanufactured or not remanufactured. That decision will go after disassembly, the cleaning and disassembly. So every time, what is happening, whenever there is an order or for a replacement part, you are also getting a core. Many times, if you see, they also pay you to give the core back to you, the warranty service providers. So harping on that, some OEMs are now insisting on reman parts for OES. In fact, many a times when you call, laptop, if you make a complaint that laptop screen is broken or keypad is broken, the person who is coming to fix it is not really putting a new one, but a remanufactured one or refurbished one to support the service. So as far as remanufacturing, I don't want to get into detail. It is use product to a new condition with equal or higher performance, quality, and warranty. This is mostly missing as far as customer understanding is concerned, because many of the customer look at remanufactured as a low grade product, which is not right. As per the definition, definitely it is tries to meet the same quality and warranty specification. The more and more customer awareness will be there, that would help the remanufacturing business and the society and environment, everything on large scale. Some current status in India, Indian Railway is doing some kind of remanufacturing, General Electric, Timken. For India, many of the firms actually also use the word reconditioning as opposed to remanufacturing. So it is loosely used. Now I'm going into completely different kind of mode. Now I'm looking at research objectives are, okay, I need to launch my, let me go back to this slide. I need to launch my remanufacturing production. Should I launch my remanufacturing production at the end of my last run when the OE production stops, so that I have collected all these cores and I should start? Or should I launch after some year, or should I launch before it? When I have a lot of core, I can also support the original equipment service on go. So this become an important question, that when to launch the remanufacturing program. Okay, so two questions: how much to launch, what should be the capacity at which we will remanufacturing, and what should be the timing of the launch. So for this, we will use an optimal control approach. At technical and operational level, we wanted to develop the optimal policies for remanufacturing operations where this part I'm not sure whether I will be able to cover this part. Why am I pointer is going? Yeah, this part I'm not sure in today's presentation, maybe sometime. The scope we are looking at exploit synergy between OE production and OEM IEM operations. So definitely already it has been highlighted that getting the core, the core is the king actually. Getting the core is the most challenging part. And since I'm looking at OES and IEM, the service providers like Ford dealership or Ford service stations, so that I can get the core back. So we did some literature review and looked at what are the different capacity planning literature is there. So we looked at decision at which time to set up the respective facility has already been made or facilities are already in place. That was limitation from capacity planning literature. Launch timing, Clever et al. Actually looked at infinite remanufacturing capacity and there was no yield issue. We wanted to bring in these features because they are very important when it comes to remanufacturing. So our focus for this research was unified approach to these interrelated decision and derive optimal remanufacturing policies. So like any capacity planning exercise, we are timing and sizing the capacity of the capacity investment. Now more complex and critical for reverse chain as opposed to forward chain, because there is uncertainty in timing and the location of the return. I mean, you do not know what part of the country the particular return for engine control module will come or engine will come. You really don't know on what volume and quality. This is have been highlighted by many researchers earlier also. And so your core are limited, you're binded by your supply constraint because you want to, remanufacture those cores. So remanufacturing program option, the first core you get and you start remanufacturing, or start after end of the OE production where you have already stocked, or start somewhere else. The idea is how do I leverage on the capacity I, erect so that I best utilize the capacity and it is cost effective. So just to show a timeline, suppose the OE sales start at time 0 and is represented by function QT, and then at time T0 you receive your first core. Okay, the first core you receive at time T0 and TP shows your end of production, OE production, and this is the time horizon. Until this point you have to provide the origin OE or IEM kind of services. On OE sales, we have imposed the residence time. Residence time in terms of that it remains with user for some time, or it could be related to reliability, but we have used that term residence time. It stays with the customer and then finally come back to the service provider. So once we take the convolution of these two, we'll get another curve, which is we are showing demand for remanufacturing parts. Demand for remanufacturing parts, we are making assumptions that every time there is a damage, I will have a demand for remanufacturing part, and that is actually my demand for service. Now there will be some yield issue. So suppose this core which I have got here, it will have some yield issue, which I am. So when I say yield, so at a strategic level, I can say every core I get, only 60% can be used to remanufacture a new part. So another 40% I need from the other core. So that together makes it one. So there will be yield issues. Keeping that in mind, what I'm trying to find in this horizon, where should I launch and what capacity I should install. So when to launch, how much capacity to install, and what should be my remanufacturing policy. So first what we looked at no remanufacturing. This was our base setting, that this is the first core return you had. You continuing with manufacturing, you are not doing remanufacturing. So all the service parts are also being newly manufactured and sent to the services. At the end of the OE production, you did a last run, build a strategic recoverable inventory, inventory for your service parts that you will deplete over the remaining time horizon. We use some NPV for discounted cash flow here. Then we took remanufacturing, that first the moment the core returns are starting, you build your recoverable core inventory. Don't do anything. Whatever service requirement is coming, you try to fulfill it with the newly manufactured part. After that, you launch your program at an optimal time, and then you support most of the uh, requirements for service demand using remanufactured part, and if there is shortage, supply the newly manufactured part. At the end of the last run, you make some serviceable inventory, not a lot, that we will decide based on our optimal control. You keep remanufacturing, and whenever there is some less or not enough cores to remanufacture, you deplete your serviceable inventory. Here we have taken one more strong, very strong assumption that service part, each demand for service parts yields one core return. But there will be issue depending on what kind of yield we are getting it. But as last presenter Eric was suggesting that they design for remanufacturing, they are trying to build products which have higher heat yields and everything. So that is also going on. So that can be controlled by the company. And based on that, what we have done, each assumption and constraint, we are saying that only a fraction of cores can be used for remanufacturing. The remanufacturing, cannot be more than your core returns. And whatever is difference between the core returns and your remanufacturing needs to be fulfilled with the new part. And based on that, we have come up with a new objective function here, that accounts for manufacturing cost, remanufacturing cost, acquisition and processing cost, holding virgin parts, that is serviceable inventory, holding core parts, that is recoverable inventory, and the capacity you are investing into. We looked at it and we found a Bangman policy which is talking about how your remanufacturing policy, how much to remanufacture in each season can be decided. The problem is that there are too many interactions going on between different timestamps. Each curve is actually intersecting with the other one at different points, and that's why it becomes really interactable to come up with a closed form solution. But we analyzed and found out that there is some situation where these kind of settings happen, that TI1 equals to T2. That means the core inventory which you are building up, if it consumed by this point, and the core inventory which you are building here is consumed by this point, we can have a closed form solution. And based on that, we have found that if capacity is greater than equal to threshold, time to launch is less than equal to threshold, you can remanufacture everything you collect. If it is less than threshold, you cannot. If it is greater than threshold and for capacity and time to launch, you may or may not. We'll see in more detail why it is like that. So we take a business case study. Actually, this we have taken some help from Delphi, which is a GM-Tier 1 supplier. Most precisely, some ECM kind of. And based on that, we put some parameter range. We look at faster growth phase, then long maturity phase, and slow decline phase for our sales life cycle, 8 years, gamma distribution. And when holding cost at the range of 12% of the unit cost, and then we to evaluate which one is giving NPV base is without remanufacturing, what you are doing, keep doing that versus remanufacturing. So this is how optimal decision structure looks like. If you look at it, this is where my structural property 1 area is, where the capacity and time to launch, capacity is greater than equal to threshold and time to launch is less than equal to threshold. I will be able to use all the cores which I'm getting. I will be make the the remanufactured part and sell it to the market. If my capacity is less than threshold, this is this area, definitely I won't be able to remanufacture everything. That is very obvious. Whether time to launch is more or less does not matter. But if your capacity is greater than threshold and time to launch is greater than also threshold, there are two areas you can see. One, you are able to use every core that has come to you, and there are others where you can't use everything. And this is the final global optimal solution. This will definitely happen in this kind of SP1 area. So this is what the global optimal solution, which will come in SP1 area. It will be somewhere over here. Now we looked at each one of them, that we can remain all returns in SP1 area. These are the different profiles it is trying to show, so that you can see that this is your the core returns, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your capacity, this is your time to launch, this is your The purple one is your yield into the returns, what strategic, recoverable inventory you are, building up in this part and then using up until the planning horizon. When you are looking at SP3 area, if you launch, just close to it, there are chances that you will start depleting it first and then use it all of them again. The idea is, since you have installed more than the capacity cost has gone up, manufacturing cost, in fact, remanufacturing cost has gone up, recoverable inventory holding cost has gone up because you are not remanufacturing anything. You start deflating from here. But serviceable inventory holding cost has gone down. After this, you do not do to use any of the OE new products. You can survive with your remanufactured products. This one we have already discussed, SP3 area, both the area you are just keep on collecting a lot of course, but you were not able to use it fully because you have less capacity. These are some sensitivity analysis. So first we have looked at new or serviceable inventory holding cost. If serviceable inventory holding cost, that is the new part, is low, if it is not high, you can hold it at a very low price. So what you will see, you don't need to install a lot of capacity for the remanufacturing. But as serviceable inventory cost goes up, that means after end of production, you have to hold serviceable inventory at a very high range. You tend to build more capacity for remanufacturing. And since you are building more capacity, what it means is you will be building large recoverable inventory. You are trying to save all those cores that can be built later. So this is the effect. And if you look at this percentage saving, NPV base minus NPV remain by, so you can see that there is a sweet point at this HN ratio. I will have the maximum saving. In both the cases, it is going down because either capacity cost is increasing or it is not at all advisable to do the remanufacturing at all. Similarly, if I'm looking at the recoverable inventory cost, which is HR, if recoverable inventory cost is very less, I will try to build as much capacity possible and try to launch the remanufacturing program as soon as possible, so that I, kind of leverage on the capacity and the, because the cost is small, I can go ahead with that one, and that will result in this kind of savings. Interestingly, when we looked at the capacity cost, the range which we are working on, what we saw that even if we increase capacity cost, it was suggesting us to be at the same capacity level. But this is probably because we have looked at the capacity which was not really looking at any extreme point. But since if you look at the cost that is involved, capacity cost into the capacity you are building into T minus TL, the time horizon and time to launch for the remanufacturing program, as capacity cost is increasing, to offset what it is saying, time to launch is increasing. If you have more capacity cost, just look at this expression. If this guy is increasing, I have to reduce this guy. This is what we are trying to do here. Finally, yield issue. So as yield is increasing, you are trying to install more and more capacities, and you are trying to yield is increasing means if the yield one core can give you 0.9 of new remanufactured product, you would be really interested to start the remanufacturing program as soon as possible. But what is interesting, you will see that neither if yield is low nor the yield is high, remanufacturing is lucrative option. The reason being, if remanufacturing yield is very high, what it is suggesting that why are you going for remanufacturing rather you go for just discard the product, landfill. I'm talking from economic point of view definitely here. And if the yield is very high, like each core can be converted 80% of the new product, you should rather go for repair or refabricating or going into the secondary market rather than installing all the capacity for remanufacturing. So I conclude here, the contribution of this work was addresses the launch timing, remain capacity planning. We tried to leverage the synergy between OE production, OE service, and IAM. This was future research. I have more, but given my health condition, The next we have looked at the uncertainty in more detail, because what happens many a time, many a times both manufacturing and remanufacturing is happening on the same line in many of the companies. They do not have dedicated. What there is discretion, how much I will use for producing the new product and how much I will use for the remanufactured product. So I will stop here. Sorry, I cannot go more because of. So any questions? I'm more than happy to take it now.
Thank you very much, sir. We'll see the questions. I request to participants, if you have any questions, you can write in the question box, or you can raise your hand. Okay, sir, I think one of the candidate, the attendee, they have raised hand.
I'm sorry.
One of the participants, they have raised hand. I'm allowing them.
Yeah, please, please, please.
So, Mr. Lau, can you ask questions to Professor Akhilesh, sir? Mr. Lau?
Lovely, you need to unmute yourself.
Mr. Lau asked to unmute. Mr. Lau, can you switch on your mic? Okay, sir, I think he is not there.
Okay, thank you very much, guys. Sorry, I was not really in good shape today. I could have involved in more discussion here, but thank you very much for giving this opportunity. It's always good to go back to your alma mater.
Thank you very much, sir. It's my honor and privilege to present a word of thanks on behalf of National Institute of Advanced Manufacturing Technology and the Futuristic Advanced Manufacturing Forum of India. We would like to express our gratitude to Honorable Speaker, who has spared his precious time for us and graced the sessions with his vital appearance. Thank you, sir, for your worthy lecture on this remanufacturing. And
sorry, I got some question, and in fact, I have faced this.
Yeah, yes, sir. This time one attendee they have.
So this I have faced with Blue Star, and actually I have to threaten them that you have to provide the service part, and then their VP and everything got into. So what they did, that's a very good observation. What they are doing, rather than remanufacturing or refurbishing, what they are doing, they are similar kind of product lines they are trying to use and fit into that. Okay, so they did not really got a 4-year-old Blue Star, circuit board. So they tried to put another one which could fit in there. So a lot of modularization and a lot of work on remanufacturing design is also going on. That's a very interesting observation. Anonymous attendee. Okay, thank you so much. Give my regards to PPC sir. And
I think, sir, we have another question. Rohit Raj.
oh, there is, yeah.
Yeah, in India, where the customer awareness is less, how can remanufacturing be introduced on an economic level?
Okay, that's a very good question from a business perspective. The thing is, tell me any ad you have seen about remanufactured product. We are lacking there, right? The people need to be told that, okay, the only reason we buy a refurbished phone and everything because of our cost region, until unless it is told to them, it will have same quality, same warranty, everything will be same, and 40%, 50% cheaper. I hardly have found any ad which comes on TV talking about a remanufactured product. That is surprising. In fact, such sessions like this, making customer aware that, it is, do not look at it as a secondary product. Look at it as if You're trying to invest into, trying to buy it at a 50%, you will have an opportunity to buy it again after 1 year, then, the new refurbished products. So people needs to become more and more aware about the economic impact on their self, the economic, environmental impact on the world. If these things are, sessions like this, more nukkad natak, all these things can really help people make aware of, the remanufactured products are really, good to go type of situation. Okay, so sir, can we get these PPT slides after the session is over? I think it is on YouTube now, right?
Yes, I saw.
I will share it with my institute, and they can, get back to you. Okay. Anything else, guys?
I think no more questions there, sir.
Okay.
Thank you. Thank you very much, sir, for your enlightening presentations here. I'm sure this may have triggered a new domain to participate, faculty and this members, researchers.
I have to visit. I have
of course, seeing in the online also, it's triggered definitely to open a new research area or domain. Thank you very much, sir. Thank you. Thank you. So now we had Professor Dr. Achilles sir with us, and the next session is on circular manufacturing supply chain from Professor Alok Chaudhary sir. So till date, Professor Alok Chaudhary sir has not joined here. So we wait for further 5 minutes. At 4:30, we predict that he may join, and we will start our session. Till then, you just join with us. So sharp 4:30, we'll see. So I request to all the participants, please wait for 4:30. I will wait for Professor Alok sir, and then we will start the further session. So now we have Professor Alok Chaudhary sir with us. I request to Dr. Achilles sir, can you stop your presentation, sir? Dr. Achilles sir.
Thank you. Actually, I started talking to someone. Let me stop sharing.
Thank you very much, sir.
Thank you.
So now we have Professor Alok Chaudhary sir. I welcome you, sir, in this session on behalf of our Institute and IMT, and the Advanced Futuristic and Advanced Manufacturing Forum of India. So before it's over to the sessions to Honorable Speaker, Professor Alok Chaudhary, sir, it's my great honor and privilege to introduce a noted eminent Professor Alok Chaudhary, sir, as the speaker of this session, delivering a lecture on circular manufacturing supply chain. He is a professor of supply chain management and the head of supply chain group at Warwick Manufacturing Group, University of Warwick, UK. His research has engaged industries from various sectors and tackled challenges related to the sustainability, resilience, and digital transformation in supply chain and logistics. His research has delivered sufficient impact on business, policymakers, and society. His research has influenced policy for the region in key growth area, including supply chain, advanced logistic, and low carbon. Hundreds of regional SMEs in the East Midlands of the UK and enhance their sustainability and competitiveness and mitigated risk through capacity building activities. He has led several national and multinational projects funded by European Union, UK Research and Innovation, and British Council. He has co-authored over 100 research publications. Recently, Sir served as a panel member of Research Excellence Framework, sub-panel as a supply chain management expert. Before this role, Sir has a professor of supply chain management at Loughborough University and a director of the Logistic and Supply Chain Program at the University of Sheffield. He was a visiting professor at a Ivy School of Business, Vienna University, IITs in India, and a visiting researcher as a Harvard Business School. He has served as a scientific committee member, session chair, and keynote speaker at several international conferences and delivered guest lecture to several universities. He is a guest editor for many international journals. Sir has campaigned strategic partnership with the world's leading universities and enterprises in India, Hong Kong, USA, Canada, Australia, Middle East, Singapore, and several European countries. It's a proud privilege to have him as today's speaker of the sessions. So now I over to the sessions to Professor Alok Chaudhary, sir. Sir, please.
Thank you very much. It's really a great pleasure to come here. Can you hear me all okay?
Thank you. Yes, sir. All are okay, sir.
And can you see my slides?
Yes, sir. It's visible.
Okay, great. So it's certainly a great pleasure to come back to Alma Mater and deliver this session. It's a, of course, matter of pride, but also one of those moments that you would like to have in your life. So I'm really pleased to come back and have a discussion around some emerging topics in the context of circular economy, remanufacturing, and supply chain. And I thought what would be really helpful to better understand the context of remanufacturing from the perspective, from a major, my macro perspective, where we are, why we are doing remanufacturing. So, and understanding that in the context of supply chain. So I will start my talk talking about three different things. One is to give you a little bit of basic understanding to the students who, for example, are not an expert in supply chain. So what exactly we mean by supply chain, what is the context, and then giving you some context of net zero. And that's a major word that we hear every day, you know, in every talk. And majority of the discussion that I will have, again, is going to bring in the context of UK. And if we talk in the context of UK, we have this major goal of achieving net zero by 2040. There are certain companies who are trying to achieve net zero by 2035 and so on and so forth. But understanding the broader context of supply chain, what role supply chain has to play in the context of net zero and circular economy. So again, going to the context of supply chain, then understanding what do we mean by net zero supply chain, and then linking, if we were to achieve and kind of create synergy between net zero and circular economy, what are the steps that one can take? And then I will use a couple of projects as an example that what we have done by working with different universities and different industries on those respect. So just to give you somebody who is not really familiar with, with supply chain context, I will start with the basics of supply chain, what exactly it is. And when we talk about the context of supply chain, when you get your food or whether you get to work on your laptop, say, for example, or mobile phone, a majority of those products are coming from somewhere else. Or if not those products, but some of the parts that's been there is coming from somewhere else. And they are coming through their raw materials that may be perhaps somewhere, maybe in China, maybe in Taiwan, then taken through road mode of transportation, taking them to manufacturer. From their different parts goes to warehouses. Then those warehouses again use different modes of transportation. For example, some products may take air mode of transportation. Some product may take, for example, road, or some products may take sea modes of transportation. And then moving into, for example, in the context of UK, somewhere on the port, and that could be airport, that could be seaport, and so on. So what we see here is that it's not that simple. And then there are a lot of interconnectivity, there are a lot of interdependencies in the supply chain. Once the product get into the country, then again, it goes to different warehouses, national distribution centers. Then from national distribution center, it goes to regional distribution centers. And from there, it goes to retailers by, again, using different kinds of different modes of transportation. And sometimes these regional distribution centers send goods directly back to your home. So this is the broader context of supply chain, or even you can say manufacturing supply chain. And within that broader context, how different industries has been operating so far. So what exactly has happened over the last few years? What we see here is that supply chain, essentially, where you have got a number of stakeholders, suppliers of raw materials, parts, components, and subsystems. Not only that, but you have got a lot of suppliers mainly for designing. And I was just, interestingly, I was talking to, I was visiting a company this week, Renishaw, and they said they have a number of their designers based in India and Pune and designing the products and the parts that they need to be manufactured in the UK. So again, those are the suppliers in terms of the designing, the prototyping, even R&D services sometimes. So suppliers of manufacturing equipment, plants, tools, specialized engineering services, suppliers of transport and logistics services, and all different kinds. You have got, if you think of the larger services like DHL, for example, in India, Cefex Group is a very big one. But also linked to that is suppliers of after-sale services, right? So you have got a lot of stakeholders and different range of suppliers ultimately to create manufacturing output that you get as a goods or service, but ultimately leading to competitiveness and innovation. But then what has happened over the last few years in the context of UK, for example, and for some cases, like the fact of COVID and Ukraine-Russia crisis, and currently US-China trade war, this has significantly impacted the way we think about supply chain. So I will give you some of those contexts where it is heading to, and then link that with the context of circular economy. So traditionally, we have seen that the supply chain in particular has got three different areas of focus. One area is mainly around the line of customer services. So customer services, we're trying to meet the customer, improve your service level. The second area is around what we also sometimes call as KPIs in operations context, cost and capital, which is what you're trying to do is to reduce the cost of manufacturing, reduce the capital as much as possible, but also improve the quality. But again, it's a balance. You cannot achieve all to the best of its ability. So for example, if you're trying to achieve the service level, for example, to the best of its quality, then it means that you will have to compromise with cost, because cost, again, if you're trying to reduce the cost, then you may have to either somewhat compromise with the service or quality. So these used to be the traditional thinking about, managing the supply chain. What has happened over the last few years, that we are moving to a new normal, and the focus areas has significantly changed. And those had changed in light of increasing supply chain risk that we have seen over the last few years. And just to start with, things like, for example, COVID-19 has posed significant risk. Now, what has happened as a result of that, in some cases in the UK, automotive manufacturing in particular, we had chip shortage. right? Now that chip shortage, because those chips are coming from a specific parts of China and Taiwan, for example. Now, if the chips are not able to reach to the plant when it is needed, then you cannot really operate the plant because chips has a major role to play. So just because of one part, companies, even like Jaguar and Land Rovers, BMW, Mercedes, all you name, they have to shut down their plant just because the part is not there when they need it. And the way it has worked in past is that most of these companies has worked believing in the principle of what we call a just-in-time. And what just-in-time means is that getting the parts when it is needed, right? So what it means that you don't have enough inventory, you don't have enough stock, and you are very much dependent on overseas suppliers. You don't have the mitigation strategy in past. So that has happened over the last few years. Number of other factors we have seen. For example, currently the major crisis we are facing in the UK is Ukraine-Russia crisis, for example, because Russia, again, there are a lot of sanctions being imposed on Russia. The political situation in Ukraine is bad, and again, the impact is not so much now, but it is going to have a lot more in the next year or so, and particularly in the context of food manufacturing, for example. But still, energy crisis, all the European countries at the moment is facing energy crisis, and the extent is such that every government that is coming, their first and foremost priority at the moment is tackling energy. Now, when we talk about energy, that's linked with manufacturing, because you cannot manufacture without having adequate energy in place. So the point I'm trying to highlight here is that in addition to the three metrics we had, three other metrics that's been added to manage is resilience. So resilience is about how you're going to manage, how you're going to mitigate the risk, how do you ensure that your supply chain is adaptable, your supply chain is responsive to cope up with any unexpected challenges, right? The second one is to do with agility. Agility is mainly about how do you ensure that you are flexible enough? How do you ensure that going beyond the concepts of lean and what we call a just-in-time, you have got enough stock, you have got enough, contingent suppliers, so on and so forth in place. And third and foremost, one of the most important one is around sustainability, and that's what the focus is going to be for rest of my presentation, around sustainability. And within sustainability, it is around environmental, social, and governance related. So the focus is today particularly around environmental sustainability that we talk about, right? So how do you going to promote the environment? It's mainly to deal with the climate change problem that we face, and that's links with the concept I mentioned around net zero. So let's move to this concept of net zero, but look at some of the trends that's been happening in the UK. UK manufacturers resource supply chain after pandemic and Brexit. You see that there's a corporate level talks, particularly at the chief executive level, that a lot more focus is on, well, we have relied too much of it on India and China and Southeast Asia countries. Let's move back the manufacturing back to the UK, back to America, back to EU, and that is happening with many of the companies that we talk today. So these concepts like nearshoring, onshoring, reshoring, friendshoring, all these are coming up as top of the agenda for these companies. But those are also linked to the sustainability issues. Now, how those are linked to sustainability issues, I will just talk in a minute. So this is I'm coming to the key element of sustainability is net zero. And why I'm talking about the net zero context is because that is what is driving the circular economy principle. Now, it's interestingly, if you look at this diagram, for example, I'm just looking at, if you look at this diagram, and this is the time frame I'm talking about, somewhere like 2005 and 2006, right here. If you see the diagram, if you look at the emission level, carbon emission level of US, that's much higher, much higher in comparison to China. But what has happened over the last couple of decades or so, that level of emission has significantly declined, right? But what is happening is that's mainly because we have been able to, and that is just an example of US, but that's also true for EU and the UK. If you look at the emission level, that has gone significantly up and up and up and much higher for China. So essentially what we have done, we have outsourced all our emission over the last several decades to countries where, and basically most of the polluting activities that's went back to different countries. Now, what is happening now? I think if you look at the diagram on the right-hand side, what you see here is the emission level. If you look at the emission level, that overall emission is growing worldwide. But if you look at the context of China and the US, China is growing significantly and the US is equivalently declining significantly. So what it tells me is that basically over the couple of decades, what we have done, we have not really moved towards the circular economy principles and different elements of circular economy focuses on net zero, but rather outsource the activities which was more carbon intensive. And that is a challenge I see, because then when you move your carbon intensive parts up to carbon intensive activities to different part of supply chain, it's still the emission. Okay, so let me go back to the, I don't know why I can't. No, oh, I didn't realize that. Can you see my screen?
Yes, sir. Screen is visible.
Yeah, but can you see the red lines on my screen as well, or just the screen?
Yes, sir. Red line is also there.
I don't know. I didn't intend that. So I don't know how to intend it to. Let me go back to the erase all those, right? Okay. So let's see to the next slide. So when we talk about net zero, and this is all in the context of the principles of circular economy. Ultimately, what we are trying to achieve is net zero, and net zero is about ultimately, it's very simple, and it's greenhouse gas emission plus permanent greenhouse gas removals, and that is what we need to do equal to zero, right? And what we are essentially trying to do with regard to principles of circular economy is trying to reduce the what we call as emission, but also trying to remove the emission as much as possible. So today, again, greenhouse gas emission greatly exceeds greenhouse gas removal, and therefore we need to have a plan for both reducing the greenhouse gas emission, but also increasing the greenhouse gas removals urgently, right? And there are a lot of challenges. So I'm not going to talk about those challenges, but rather focus on, ultimately circular economy has been used as a principle that we can embed at the product level, at the process level, at the plant level, at the regional level, at the supply chain level, to reduce the greenhouse gas emission and increase the greenhouse gas removal. So when we talk about greenhouse gas emission, what exactly we mean by that, and linking that in the context of supply chain. So it's important to understand that at the moment when we talk to any companies, particularly in the UK, the focus is predominantly on a scope 1 and a scope 2 emission. Now, what is that scope 1 and a scope 2 emission? Just trying to understand those elements. So a scope 1 emission is coming from your operation, your manufacturing facility, under the what is under your facilities control, where you manufacture something within that facility, whatever emission is coming, including on-site fuel combustion. And that's what we mean by scope 1 emission. So again, for the students who are participating, if you hear about the terms like a scope 1 and scope 2 and scope 3, scope 1 is about something which is coming from your facility and that is within your control. A scope 2 is slightly complicated, emission from uses of electricity, steam, heat, and cooling. So again, a scope 1 and scope 2. And these are the two where a lot more focus has been placed. Interestingly, we need to understand what is scope 3 emission. And a scope 3 emission is what is coming from your upstream and downstream of your supply chain. So emission from procured products and transport of supplies, business travels, through to emission from transport of products to the sold products, to the use of what we call as those products. And I would like to give you some example that why scope 3 is increasingly important. The challenge here is that I'm just using an example of a couple of companies, right? Siemens, many of you have heard of Siemens as a global brand, you know. Around 90% of their carbon emission is not coming from their own operation. It's not coming from their facility, the one that I mentioned on scope 1 and scope 2, but actually coming from their suppliers, 65,000 of their suppliers that is based in 140 different countries. And it's interesting statistics here. Now, I'm talking about another company, for example, that I work with called British Telecom Group, very large company, multi-billion company, you know, have got thousands of suppliers across the world. In their case, it's again slightly more of their emission is coming from. So 69% of their emission is actually coming from the suppliers and 24% is coming from the customer's use phase. And that tells you the extent of, you know, if your ultimate aim is to reduce the greenhouse gas emission, where the ultimate focus is on. And unfortunately, the focus predominantly at the moment is still on scope 1 and scope 2, ignoring the fact that majority of my emission is coming from the supply chain. But again, at the same time, there are a lot of things that's been happening with regard to Siemens. For example, they are developing what we call as carbon web assessment that encourages their suppliers to optimize their emission. They are developing, for example, a green digital twin, which kind of develops a replica of their supply environment and looking for opportunities to mitigate those. They incorporate these principles into their purchasing decisions. They have developed their network, cross-company collaborative network. They are implementing technologies such as blockchain and digital twins to improve that. So although they understand that, you know, a lot of emission is coming from their supply chain, they are making progress with regard to that. Now, again, this is interesting to understand that if we talk about a scope 1, a scope 2, and a scope 3, where is the major, what is the major emission coming from? Now, if you look at these different industries, 8 different industries on the right-hand side, these 8 supply chain account for more than 50% of the global emission. Right. So again, the priority should be, if you think of like, you know, things around electronics, construction industry, automotive industry, food, fashion, FMCG, those are the major one where majority of your emission is coming from the supply chain. So why do we need to focus on supply chain? Because majority of your emission is coming from your supply chain. If you are following the principle of circular economy, again, you need to be able to focus in the context of supply chain, not just focus in the context of one manufacturing process or one manufacturing, what we call as product. On average, supply chain emission is 11 times the emission of the company. UK government, and in fact, government across the world now increasingly are committing to what we call as net zero targets, including India. There's a lot of regulations coming up that is being imposed on companies, which basically forces them to think from the perspective of supply chain. So what we are trying to do here in terms of my research is placing the supply chain at the heart of delivering net zero, because that's where the focus is on. There are a lot of challenges in doing that. You have got the measurement and reporting challenges because there is no what we call as a standard and what we call as homogenized approach of measuring and reporting your supply chain scope 3 emission that we talked about. The another problem is that data challenges, the transparency and data sharing and double counting, it's too difficult because your data challenge is majority of your data is actually coming from your suppliers. And I'll just give you a simple example of leading automotive manufacturing company in the UK that we work with. And interestingly, what is most interesting is that they won't disclose anything to their suppliers. I mean, even if the fact that they are, paying millions of pounds to their suppliers, say, for example, annually, still they won't do it. And that is the problem because they don't have the trust, they don't have that kind of collaborative agreement to work with their suppliers. There's a lack of policy, governance, and harmonized standard. There's lack of guidance and support for companies. In addition to that, a lot of challenges around supply chain, issues related to suppliers, your procurement, your collaboration. activities, the sourcing, business models, incentives. If I have to go for like net zero, why would I do that? Why should I bother? If I ask my suppliers to do, or can you just use renewables, say, for example, can you fully follow the principles of, circular economy, say, for example, in India, they say, what's my incentive? Right. So unless we have that business model, where we incentivize our stakeholders, it's challenging. Lack of collaborative platforms or solution, knowledge sharing platforms, learning best practices and tools, but also understanding that a majority of the business or SMEs, they lack resources, they lack competencies to decarbonize their supply chain. So there are a lot of challenges that already exist, and going forward, a part of our research basically is trying to address these challenges. And with this one, I would like to use some example of some of the leading companies, that what they are doing. So if we look at this diagram, right, it's a 2x2 framework. Differently, how you work with your suppliers to kind of engage them in the process of decarbonizing, right? So on one hand, the incentive could be non-financial, but on the other hand, the incentive could be financial, right? On one hand, the suppliers are rewarded. On the other hand, if they don't follow the principles, then they are penalized. And based on that principle, I will just use some example where we specifically talk about these companies where they leverage procurement as an activity. For example, companies like British Telecom Group, they put carbon reduction clause in their agreement with their suppliers, right? They include decarbonization criteria into their procurement activities, right? They mandate their suppliers to report the carbon emission. And these all leads to this what we call as leveraging procurement as an instrument to net zero. And that basically then lead to another aspect which we call as capacity building. So in this capacity building, again, companies, say, for example, like Shell or PepsiCo, for example, they work with, their suppliers, and in that approach, they encourage those suppliers, they reward their suppliers through public recognition by training them, upskilling their employees, sharing learning and best practices and resources, and benchmarking with their peers. And by that way, they are able to achieve it, although it's there's no financial penalty, but reward existing here. So what we have got, on the other hand, companies like PepsiCo and Shell, they engage with their suppliers to build their capacity through a number of activities that you see here to decarbonize their supply chain. Now, on the third hand, when we look at companies, say, for example, like Microsoft, it's an interesting one, which is basically enforcing the performance. They work with their suppliers and they say, well, if you don't follow the principles, you will be penalized. If you don't follow the principles, your contract will be terminated. So on the other hand, in contrast to BT, for example, Microsoft, and say, for example, Philips, they would have a different approach where they are using a penalty-based mechanism, and also what we call as financial implications to work with their suppliers. And the topmost one that you see is both rewarding and financial. Companies, say, for example, Dow, it basically is around the rewarding the progress. What you do is that you work with your suppliers and you pay for the performance. The better they perform, the better reward they get, right? So they have the beneficial payment terms. You offer, if the product is green, then you have the higher product price. But also, if you have the longer term investment, you work with them, with these suppliers, to tackle and invest in technology, in remanufacturing plants, in circular economy principles, considering on a long-term basis, because you cannot just have, the relationship for a year or so. So you need to have a long-term relationship and long-term investment when you go about implementing different, again, even principles of circular economy. So when we talk about, I'm not going to go into the details of this, but rather focus a little bit more on this company, British Telecom Group, how they do go about decarbonizing the supply chains. They work with different suppliers. They encourage them to report. They work with their suppliers to actively use renewable energies. They add sustainability clause in their supplier contracts to achieve that. And again, here the principle is that now coming back to the second element, element, which is to focus on what principle, how do you go about decarbonizing your supply chain? So you look at creating transparency, you look at the exchanging data with your suppliers, you set ambitious targets, you optimize your carbon emission in your supply chain. That means that you redesign your product, you design your sourcing strategy, you look for engaging with your suppliers, you develop metrics and metrics and what we call as procurement standards in the contract, and then push the ecosystem. So it should not be possible that one company, is leading, but rather you need to engage with the whole ecosystem to promote best practices and so on and so forth. So that gives you an idea of the decarbonization strategy in the context of supply chain. Now, where that links with the circular economy concept, again, I'm not gonna, I just assume that you know the basics of circular economy because of the nature of this conference. So again, a circular economy is a systematic approach to economic development designed to benefit businesses, society, and environment. And in contrast to the previous business model, which was linear model, take, make, and waste, through to a more circular, regenerative by design, and aims to gradually decouple growth from the consumption of finite resources. And this is again a part of model that we have developed. And this model is again for a region. So as I said, circular economy principle, you can apply for a product, you can apply for process, you can apply for a plant, you can apply at the supply chain level, but you can also apply circular economy principle at a regional level. And the reason that we belong, for example, in the UK is called Midlands of the UK. So what I'm presenting is here is the going beyond the circular economy. We are linking that with what we call at net zero principles. So when we talk about the net zero principles together, we develop this 2x2 matrix, 2x2 framework to guide industries towards overall greener production within a particular region, right? So this combined approach, which combines net zero, which I have just talked to you about, and the circular economy principles, consider the climate impact of raw materials, manufacturing value chain, unlike using fossil fuel focused on plant-based renewables, reducing carbon emission, and growing the use of recycled remanufacturing and reuse of products, and ultimately trying to minimize the climate impact, basically. So if you look at where we talk about the low carbon manufacturing, and the circular economy principle is mainly using the conventional approaches to manufacturing, but how we can move from there to a more energy and resource efficient way of manufacturing that combines the principles of net zero supply chain and circular supply chain. If we look at in this matrix, specifically, we talk about, where the circular economy principles are highly applied, you look for ways to resource efficient ways of manufacturing. And where we look for ways to, for example, focus more on just the net zero, we look for more energy efficient ways of manufacturing. And these principles basically help us to combine a framework that allows us to combine circular economy principles and low carbon principles. And again, in the form of a framework that will kind of help industries and a particular region to kind of be more resource efficient, but at the same time also achieve the targets of net zero. Now, again, going back to the net zero archetypes, the method that we developed, again, that combined a whole range of literatures that exist already there, but also engaging with a number of stakeholders, right? And this methodology covers both macro level and micro level. So at macro level, the focus has been mostly around energy generation, where we look at energy generation resources, majorly defines the carbon emission level. Greener power means less carbon footprint. Energy transmission, again, a lot of energy is wasted during the transmission process. So how you can improve the energy transmission process efficiently. In that, mainly you look for things like, so for example, in energy generation, the focus has shifted more for hydropower, nuclear power. Recently, we have a couple of nuclear power announced in the UK: wind power, biogas, hydrogen, municipal solid waste, biomass, solar, and geothermal. When you move for the mechanisms or potential solutions for energy transmission, looking at ultra high voltage transmission along the line of dynamic line ratings, wireless electricity transfer through to power flow controls, topology optimization, all these kind of potential solutions and technology developed to achieve the net zero in the context of energy transmission. And then relates to energy storage, which is to do with energy storage and transmission, again, mainly using mechanical storage to do chemical storage, thermal storage, electrical storage, and electrochemical storage. And then finally, trade, where the focus is, again, in terms of potential solution, is on emission trade, energy as a service, energy trade, and distributed energy resources. Now, again, taking this to at more micro level, where we looked at goal defining, so understanding the concept. So that starts with the understanding the concept through to carbon footprinting. You cannot really have a net zero at the micro level unless you understand the process, understand the emission profile, you audit for the carbon footprint. You understand and you categorize the emission, you avoid any distribution of emission. You look for, looking for opportunities where there's a potential for decarbonizing your product or processes or even your supply chain. And then again, defining the short-term, mid-term, and long-term goals, which will enable you to achieve that. Again, in terms of if you look at the internal operations, you think of from the perspective of design, where you look for greener product, greener services, greener facility. If you look from the perspective of decarbonization, you look for challenges around carbon capture, carbon storage, carbon reuse. To do energy consumption, where we look at energy selection, energy efficiency, and reducing the usage. But again, the majority of these are not possible without external cooperation. So you work with the select sustainable partners where possible to achieve your green supply chain. Second, looking at develop and applying reasonable carbon KPIs and timeline according to all supply chain business unit situation. Promoting training and incentive plans to motivate the supply chain towards decarbonization, and sharing knowledge of low carbon supply chain to achieve the net zero goal. Now, that is from the net zero perspective. Now we bring that from the perspective of circular economy. Again, I'm not going to explain this context of recover, recycle, reuse, reduce, and remanufacture. But ultimate purpose is to reduce the waste as much as possible and increase the what we call as the resource efficiency. At macro level, we look at the supply side, your supply chain, mix of both, and demand side. And by that, you look for, what we call as your directing activities, that how do you go about directing the strategy of your supply chain? So establishing a national long-term plan towards circular economy, which is the fundamental. So essentially, to start with the directing element, where you, just to give you the context, for example, EU, for example, have got their own plan around circular economy. UK has got their own plan at the national level around circular economy, and that is now happening more at the regional level. So, for example, we in the Midlands are mainly worried about, okay, how are we going to implement those policies and plans at the regional level? How we can bring those stakeholders on board on the ground, different companies, large and small, to help them achieve this national plan that we have. The second one is around regulation guiding, which means that providing enough detailed regulation as a guide and restraint to the companies and publics to implement the different circular economy principles. Promoting different technologies that exist and leveraging related technology, and specifically around digital technologies, where we talk about things around Industry 4.0, additive manufacturing, whole range of technologies that is going to promote the circular economy principles. Then symbiosis testing, essentially to think from the perspective of industrial symbiosis parts, to test and identify the opportunities of circular economy, where you have got a number of companies co-situated together, where the waste of one company could be used as a raw material to the other company. So again, symbiosis testing. Incentive encouraging essentially is to do with providing incentives for company and consumers to motivate them to change. And finally, and is around image building. Now, what is happening is that circular economy principles, I'm not sure if you have seen, but even companies like IKEA, a number of companies now started to kind of retake back the old furnitures, and in return, they give incentives to the consumers. And that basically helps consumer to kind of, resale or reuse the product that they have been using. At the same time, results monitoring to do with continuously monitor the process results of circular economy that changes dynamically. And last but not the least, as you know, I was just talking to kind of I was watching the last session and somebody asked this question around remanufacturing. Essentially, it's also people need to be educated about the principles of circular economy and net zero. So continuously educating, advertising to the change, to the consumer's attitude towards circular economy. I won't believe, you know, it's interesting that whenever I teach these topics in my class, for example, I use India as a great example, mainly because I think I still believe that there's a lot more opportunities there for circular economy, and also not only the opportunities, but the practices. And again, going back to the principles, like, you know, if you remember things like few years ago, I'm sure it will be the case there now as well. We used to have Kavariwala basically coming to get your all the iron and your what do you call vessels in your kitchen, and then in turn giving you some incentive. You know, they buy those products, and in return they give you something financially or as a product. And that is a fantastic example of circular economy. The problem there we face in the UK is that unfortunately those things does not really exist. And if it does, then instead, you know, they're paying us. You have to pay to kind of you know, what you call as recycle those unwanted items. So great example here. And again, as I said, public needs to be educated along those principles. So on those bases, combining those at the micro level, circular economy archetype, we develop a model, what we call a circular economy disrupt model, which basically takes into account the different concepts that we talk about. So for example, previously we talk about goal defining through to external internal cooperation through to external cooperation. Now we combine that in the form of what we call as a framework, which is called disrupt. Disrupt is essentially where we're looking at first principle is design for the future. Now, this is the problem. When in industry we design, you know, any product or processes, we think for now consideration. I will just give you an example here. So this week, we have been visiting a company called Renishaw, very popular, you know, it's a very much into metrological instrument. And they said, look, you know, we develop products and services, but what has happened is that when we develop product, essentially it was mainly, more often we have to kind of look back to our design, because that is where every production starts. You know, so if you're thinking of a product that you're going to sell to your customers, ultimately you have to start the design, right? So their current assembly process was you know, mainly humans operating on the assembly line. And the challenge, they were looking for ways. They have sudden demand increase, and they cannot change you know, bring the robots that they have to produce those products. So why they can't do it? Because when they design the project, they've always felt that this is always going to be operated by a human being, right? But now we have got the robots who are doing the assembling at our assembly plant. So essentially, even in the context of circular economy, when you are thinking of the future, you are designing the product, you think that you focus from the future perspective. You make sure that your design is future proof. The second element is around incorporate the digital technologies. So digital technologies, essentially, as I have already mentioned about different elements of digital technologies. The third one is around sustain and preserve what's already there. What you would like to do is to sustain and preserve as much as possible, both in terms of the raw material or in terms of the goods that is there. And, you know, classical example is how you can remanufacture a particular machine, say, for example, or how you can what we call as repurpose particular goods or services. Rethink about the business model that you have done. Instead of just buying and throwing, can we have the leasing model where you know, the companies who are, and it's happening already with regard to many of the companies in the UK. For example, Rolls-Royce, a fantastic example. Their business model nowadays, they don't sell their aircraft. You know, their business model is very much interesting, which is the number of hours aircraft is in the air, the number of hours the engine of that aircraft is running. That is what will generate the revenue for Rolls-Royce. Now, the interesting fact here is that now, if you think from that perspective, that the benefit the company gets that they don't have to worry about the aircraft, and Rolls-Royce would like to, because they have to increase their revenue, they would like to make sure that their product is durable as much as possible, right? Same is the case with automotive manufacturing that's moving. Say, for example, you talk about companies like BMW, Mercedes, or even things like Jaguar and Land Rover. The U refers to use waste as a resource. The more and more you can use waste as a resource, the better it follows the principle of circular economy. Prioritize regenerative resources, team up to create joint value. So integrate with your supply chain to ensure that you create value for your supply chain. And then, of course, we talked about number of indicators that you can use. So, for example, resource output rate in terms of the output of energy, output of mineral resources, different indicators that you see under the headings of resource consumption rate, integrated resource utilization rate, secondary raw materials. All these could be used as an indicator to what we call as promote circular economy principles. Now, I think I have got something more to discuss, but I would rather give you a little bit of glimpse of a project that we have recently also finished called circular materials for transportation. And what it means is that if you think of different modes of transportation, right? When I talk about different modes of transportation, I'm talking about road mode of transportation. In road, you have got bus, you have got cars. If you think for the rail mode of transportation, you have got trains. Interestingly, I was visiting a company called CAF Group, and they are basically rail manufacturer. And looking at the way they kind of produce, rails that you kind of travel, it's very, very fascinating. So second is rail mode of transportation. The third one is ship mode of transportation. Like somebody may, when you're moving from one continent to another continent, or majority of the times goods are moved using ship. And the fourth is aerospace, right? So air mode of transportation. So interestingly, what we were looking at is, at the moment, what is happening is that each mode of transportation has a linear, what we call as linear supply chain. So in terms of circular economy, they are promoted linearly, right? And what we were looking for is that how we can promote the cross circularity of materials across different modes of transportation, right? And I will give you just some idea around that basically. So the focus was on how we can identify cross transport materials and identify the opportunities for their what we call as from design, manufacturing, and end of life perspective. What are the opportunities exist so that we can promote the cross circularity of materials across different modes of transportation when they reach to their end of life? And if you look at the four more major materials identified: steel, aluminum, composites, and plastics. And again, they have the challenges and the opportunities at each stage of circular economy potentials measure. So design and manufacturing and end of life. Not going into the detail of that, but giving you a little bit more glimpse of the model that we developed, what we call as a ROSE framework for transportation machines, mainly around. Now, again, you cannot, when you look at the practicality of it, it's very difficult to kind of what you call as remanufacture or what you call as recycle every materials. So after the investigation, engaging with industry, engaging with what already exists, we came up with this ROSE framework, which allowed us to develop a framework for promoting cross-circularity of materials in the UK in particular. So if you look at different materials that in this, what this ROSE framework is around, it is specifically focused on what we call as re-engineer, optimize, share, and exchange. And within this context, we looked at these two materials, particularly steel and plastic. So in the context of re-engineer, it was mainly to do with what we call as design for recyclability, material use reduction, design in use optimization, design for disassembly, material substitution. Then optimize phase mainly look for use of recycled secondary materials, optimization of production, increased use of additive manufacturing. And then when it comes to share and exchange, the emphasis has been placed on remanufacturing, of steel and plastic end-of-life products, resell, reuse, and refurbish, closed-loop recycling, product reprocessing, and open-loop recycling and reprocessing. And this basically framework allowed us a mechanism that companies can use to kind of navigate the cross-circularity of materials through different modes of transportation. If somebody is more interested in the roadmap, so again, as you know, it's an ongoing project, and what we are looking for, what is going to happen in 10 years' time, and how we're going to implement this framework extensively in companies. So we came up with this framework and a roadmap that will allow, for example, for the remanufacturing and the use of plastics in transportation sectors. So we developed this framework. Not going into the detail of that, but happy to. Anyway, I will be sharing these slides. So please feel free to ask any question you may have. Same is the case with steel, developing a framework that allowed the promotion of circular economy principles for steel in different modes of transportation. And that's where I will stop given the time. So I'm happy to take any question you may have, and happy to share the slides.
Thank you very much, sir, for your in-detail presentation about the circular manufacturing supply chain. So how you have efficiently described the circular economy is a resource-efficient ways of manufacturing. Thank you very much, sir. So now the question answer session is open for all the candidates participants. If you have any question, you can write in a question answer box, or you can raise your hand. So request to all the participants, if you have any question, you can ask. You can raise your hand. I think till date we do not have a question, sir.
That's great news. That's always good to know. Again, I think the approach that I was coming from, again, we are taking a more business perspective, not the technical perspective. I mean, there are fantastic researchers and scientists doing fantastic work around circular economy for products and processes, but the angle that I was coming from more was from the perspective of supply chain, to better understand what is the. So there is a question on the investments are in green energy are highly intensive and not reliable. So how can we deal with it? Again, the answer to this question is very simple. I think there's a policy implications here. So there's this question that has come on from Rohit talking about the investments are in green energy are highly intensive and not reliable. Not reliable. So how can we deal with it? Now, that's very true. And if you focus, so first of all, as I said, the drive is coming from the globe, right? The drive is coming from this net zero policy and regulations. We have got the climate change mandate. We have got the what we call as net zero targets, and to achieve that, we of course need investment, and that investment needs to come from different sources. Particularly, for example, there's a lot of incentives to actually come from government. If government is mandating firms to go for green resources, then it needs to support those objectives. So, but imagine a situation. I give you this example of net zero. Imagine a situation you are selling a product, and that product is, say, for example, is sold in the UK, right? And the company that you are selling in the UK is asking you, well, actually, your product is very resource, which is coming with a lot of carbon emission. But now I have got this responsibility to reduce my carbon emissions. So I want you to use, less carbon intensive sources. Now, if you were to sell your product to these companies, of course, you have to fall in line, because you cannot, survive without the support of these companies. So there are different mechanisms that you can use. For example, policy implications. I already talked about different business models where you are incentivized to doing such thing. It means that, of course, the product price will be slightly higher, which is always the case, right? The product price will be slightly higher. But ultimately, what we are trying to do is to, again, coming on to that supply chain level where you're trying to account for the emission that you may have. it's completely right that reliable in the case that they are still in the initial stage in comparison to existing technology. So that's true. But we have it's been advanced. It's advancing. You know, the way I see it, it is progressing is that. And that is always the case, that a lot of innovation is happening in India. If you look at, I mean, I look at things around hydrogen production in India. I mean, amazing to see the different, you know, companies coming into the line of hydrogen production. And that's another area of research I'm involved in. I mean, hydrogen production is still unreliable. I mean, it's at least even from the UK perspective, but a lot of technological advancement is happening. Now, to give you another example, in the UK, we are mandated not to buy, there will not be any diesel car in the UK produced from 2030, right? I mean, that's a mandatory sort of thing. So you as a consumer have no choice. So there's a lot is happening from the perspective of battery manufacturing and electrification and so on and so forth. And as you have rightly seen, there are a lot of incentive being at the moment, the threats that is coming, for example, in the UK from Russia and the Ukraine crisis, just that led to like two nuclear power plant being installed in the UK. So those kind of, you know, again, sets the stage that policy, government, stakeholders needs to come on board to address those challenges. Yeah, so I'm more concerned about time. And again, I'm sure there is another speaker. So I really enjoyed this session, and definitely, you know, thanks for inviting me for this session.
Thank you very much, sir. So I would like to present the word of thanks on behalf of our organizing committee. We would like to express our gratitude to honorable speaker, who has spared his precious time for us and grace these occasions with his gracious presence. Thank you very much, sir. How you have explained very well about the supply chain, how and what supply chains and why do this matter, carbon emission, how 80 to 90% emissions for coming from the supply chain and net zero supply chain challenges you have explained very well. Thank you very much, sir. Thank you, sir.
You're most welcome. Thank you.
Yes. So now we have another honorable speaker with us, Professor Sandeep Mandal, sir. So before we go to the sessions to the Professor Sandeep Mandal, sir.
Yeah, good evening. Good evening. Am I audible?
Audible. Good evening, sir. Welcome
Good evening.
in the sessions on behalf of our organizing committee. This workshop is jointly organized by National Institute of Advanced Manufacturing Technology and the Futuristic Advanced Manufacturing Forum of India. I'm Dr. Jagiswar, coordinating these sessions. Before we go to the sessions to the honorable speaker, it's my indeed privilege to introduce our distinguished Professor Sandeep Mandal, sir, from the Department of Management Studies, Indian Institute of Technology, Indian School of Mines. Now it is IIT Dhanbad. So as a speaker of this session, delivering a lecture on reverse supply chain, prospects and challenges. Sir did his BTech in manufacturing engineering from National Institute of Foundry and Forge Technology, NIFT. Sir is an alumni of institute, NIMT. Now it's National Institute of Advanced Manufacturing Technology. He did his BTech in 1998. He has done his MTech in Quality, Reliability and Operational Research from Indian Statistical Institute, Kolkata in year 2000, and completed his PhD in Management from Indian Institute of Technology, Dhanbad in year 2006. His research area are decision science, quality management, remanufacturing, green supply chain management. Sir is the author of more than 45 high-impact journal papers, 8 edited books in his credit, and 8 edited books as a chapter international. He has completed 4 sponsored projects and 1 is already ongoing. He is a member of editorial board of Journal of Remanufacturing, Springer Verlag, Germany. He is a reviewer for International Journal of Production Economy, IEEE, Transaction on Engineering Management, Management Decision, Journal of Manufacturing Technology Management, International Journal of Remanufacturing and Benchmarking, and International Journal. Sir is guided more than 10 PhD students. It's our proud privilege to have him today as a speaker of the session on reverse supply chain, prospects and challenges. So now over to the sessions to Professor Sandeep Mandal, sir. Sir, please.
Thank you, Professor.
Thank you, sir.
Yeah. So I think the screen is visible, PPTs.
Screen is visible, sir.
Okay. So thank you very much. So I'm very happy in basically in two couples of things. I was a bit excited also because of the first reason that when you talk about workshops and conferences related to remanufacturing, particularly in India, hardly such kind of basically talking about remanufacturing, such organizations are very rare. Globally, though, there are conferences are being organized on remanufacturing and workshops. And second point is because of I'm talking to my alma mater, so I was very happy to talk to the students of NIMT. So my topic is on reverse supply chain, talking about prospects and challenges. Am I a bit audible? I just want to confirm it.
It's audible, sir.
Yeah, okay. And the screen is scrolling?
Yes, sir.
Okay. So I'll just talk a bit of strategic management decisions. Basically, when you talk about reverse logistics or reverse supply chain, and in context to remanufacturing. Now, when you talk about remanufacturing, though globally it has been very popular, it has been considered to be a mainstream business, but in India, still it is in the nascent stage. So I am almost working in Indian scenario for almost 20-25 years in the area of remanufacturing. Still, more initiatives are required from the part of the stakeholders, from the industry, from the government, to set up as basically an organized sector. So it is the students, the next generations has to come forward, pick up research, pick up as a business, so that it can be popularized in the Indian context. Even globally also, you will find very few journals, especially there's a journal of remanufacturing, and Eric is basically the editor. Luckily, I am also the part of the as a editorial board in that journal. So that is I think that's the only journal which is basically dedicated to remanufacturing research and publications. So, but however, there are still a lot of things to be done in Indian scenario. So I'll be basically focusing on my discussions, my all ideas from my experience, and talking particularly to the new generations to pick up some research or pick up as an area of study. So before moving into this reverse logistics, I'll just give a brief background. Maybe I'm the last speaker of today, so you'll be loaded with informations related to remanufacturing. So just a recap of what we have seen today maybe. So remanufacturing is basically considered to be as one of the 5 product recovery options. So this was basically proposed by Thierry in 1995. So he has proposed such kind of product recovery options like repair, refurbishing, remanufacturing, cannibalizations, and recycling. So these are basically been classified based on the level of material you basically extract. So maybe we are doing all these operations, this kind of exercises, activities has been done in this organized sector. But when you talk about remanufacturing is basically talks about disassembly of parts and components of used products, or we consider it as a returns. And these disassembled parts and components thoroughly inspected, defectives are been and worn out parts have been repaired, technological upgradations has been done, and you keep the identity of the product. So you don't lose the identity. Whereas in recycling, material has been extracted. In cannibalization, we extract parts, chips, ICs, and other things. So that is basically some higher level of recycling, where you try to retain as much value or extract as much value which is retaining in these used products. So some of the prime motivators which has initiated this industry, basically it was the environmental laws, take back obligations, and disposal bans. So this was one of the prime reasons why companies have taken up. But before laws, there are many companies like Xerox, Volkswagen. They basically initiated looking the economic benefits from this process, this activities of remanufacturing. In the sense, they could retain. They have found that there are many parts, modules in these products which can go for 2-3 life cycles. So instead of disposing this valuable resource, they thought of circling it into the economy. So they found it a lot of economic benefits. And of course, nowadays, environmental issues and other things have been popularizing globally. So customers are also become aware. They are becoming conscious of using the recovered products or recycled products. So that's also the other reasons. Then the fourth reason, which also we found it, particularly in Indian cases, there is a demand for spare parts during the post life cycle of the products. So once the product life cycle is over, so for repairing of modules or changing of modules, many companies, what they are doing, they are extracting, they are remanufacturing for parts and components to fulfill the demand of spare parts. So basically, this is the background of how this remanufacturing activity started. Now, this is just a diagram to show the different activities which goes on in the whole chain. So it starts with the used and discarded products which have been either bought back or collected or through exchange offers. So this is an acquisition of returns. So this is a very big activity, acquiring these used products. So why I'm just representing this? To show that where the complexities lies, how remanufacturing complexities are a bit unique with comparing to manufacturing processes. And these complexities makes this decision making of the remanufacturing process bit difficult in either you do for production planning or transportation planning or your other things. So acquisition of returns is a very important activity which goes into this chain, where we try to identify the returns, which we determine the value of these returns through age, usage, And there's another activities like setting up of a network of collection centers. How we will be collecting these used products? That's a very difficult task. As compared to manufacturing, when you talk about manufacturing decisions, we consider the availability of raw materials to be a deterministic kind of thing. There are markets, there are suppliers who will be supplying materials for your manufacturing process. But in remanufacturing, the major chunk of your raw material is the used and discarded products, which is in the market, which is with the customers. So locating them, acquiring these used products from them is really a very big task. And these components, these activities together, basically starting from acquisition till the collection center, till you bring it to the remanufacturing plant, this part basically is termed as a reverse logistics. And there are certain issues which makes this reverse logistics process very complex. The first issue is talking about uncertain timing and quality of returns. Because to have a smooth remanufacturing process, we have to also ensure that there's a smooth flow of raw material. So since collections of these returns is becoming a bit complex because of the uncertainties, I don't know when the customer will return, at what quality will be available these returns. Then there's an uncertainty about how much usable materials will be recovered from these returns. So there's a requirement of a reverse logistic network, isn't it? So this again is not similar to the logistics that we consider in normal manufacturing process. We have to think in different, have to have different planning exercises. Moreover, there's an issue of balancing these returns with the demand. So we have a demand of remanufacturing products. So these issues basically, like uncertainties, logistics and other things, these makes this process a bit complex, particularly the reverse logistics part. Apart from this, there are other issues like disassembly, which is not there in the manufacturing process. Then there's a issue of materials matching, stochastic routing because of high variable processing time. So these issues will make difficulty in the processing of or assembly and disassembly of the used products. So we'll restrict ourselves to the topic talking about how we can manage these issues in the reverse logistics chain. Now, talking a bit of Indian scenario, we have conducted a survey, I think last 4 or 5 years back. So it was basically done among the industries in India, Indian industries particularly, to find out why remanufacturing business is still not been considered as a mainstream business. So this was a government-sponsored project basically to frame up some kind of policies. So we could find these are some kind of snapshots I just taking from that study. So we could find that some of the reasons which was found to be, this was the opinion from the industry people, reasons like complex and costly reverse logistics system. So most of the manufacturers are a bit familiar with the forward logistics systems, but how to manage a reverse logistics system within their constraints, how to manage within their limited resources is a very tedious or very complex issues. So that is the primary reason they have found it. And the companies which are really practicing, which are existing in India, like Volvo, Cummins, and some other companies are there who are doing remanufacturing business. They also found that the cost of this reverse logistics system basically constitutes around 10 to 20% of the whole system. So this is a very costly part they consider to be, and of course a complex issues also. The other reasons which was found, like the market in terms of acceptability of this remanufactured products in the Indian markets, basically. So maybe unawareness of the Indian customers. The other reason which was found, basically literature says that the laws and regulations were basically the prime drivers. But in Indian case, we found it a bit different. We could found that the economic benefits was can be a prime driving force rather than legislative compulsion in Indian business scenario. So that was the interesting finding, and we could also justify because as Indians customers are bit price sensitive kind of customers. We look for prices. Even if you go for markets and other things, we start bargaining things. So Indian market is basically a price sensitive market. So maybe because of that reason, if you could highlight the economic benefits of remanufacturing, it would be much more popularized rather than setting up only laws and other things. Then there are some other findings we could get it. These are basically, we did industry classifications also. So based on different industries, what was the major reasons for unpopularity? Like say computers and electronics, they talked about technical infeasibility was the major reason behind this unpopularity. Industrial machinery, mostly the machine tools and heavy machines, talking about earth movers. So they talk about complex reverse logistics as a big issue for them. Automotive industry, basically, they focused on customers' unacceptability of remanufacturing because of maybe the second-hand market which is existing, which is very thriving in automotive sector. Maybe because of that reason, remanufactured products, remanufactured cars or remanufactured bikes may not be popular in such case. But they talk about creating spare parts. So this is just a background of Indian scenario. Now, talking about some of the decision areas in reverse logistics, we could identify that in reverse logistics or activities could be managed by these 5 different activities. Popularly, it's a return acquisition management, then the transportation issues, inventory management. So popularly, these 3 forms a major set of activities when we focus only on reverse logistics. Other are basically talking about the plant operations and the market demand side. When you talk about return acquisitions, there are different sub-issues we could identify, like locating of the course. Course basically talks about the used products, where to find, who will be where we'll get these used products. So that's a very difficult task, isn't it? So that companies needs to devise some kind of model, some kind of network has to be designed. How we basically identify customers will be returning back those things. So some ways through which you can do the collections are available in literature, like take back. So take back through exchanges, maybe exchange offers and so on. Buyback. So buyback is offering certain kind of prices. Okay. So instead of giving some used products. So that's the other mode of collections. Leasing is another kind of ways through which you can collect. Then there are auction centers. A lot of auction centers like e-waste and other things have been collected through auction centers. Seed stocks are basically available in industries when unused, maybe those are obsolete kind of stocks which needs to be disposed of. Then warranty returns. So this is another way of getting these used products. Then the different agents which are involved in collecting these used products can be the OEM himself, or they can engage some third party logistics providers, or they can create some kind of take back centers. So these are some of the agents I collected from the literature. So there can be other modes of other agents the company can devise through which they can think of collecting this used products. Then take back period is also very important. So take back period basically talks about that what should be the optimal age of your returns. If I take very old products, maybe I will not get the economic benefits. I will think of again then recycling those things. So you have to think about the decisions. What should be my take back period? Then also this is very important, the quantity of returns. Basically, you have to ensure that your remanufacturing business runs. Your process has to be fed with this used product. So we have to fix this quantity based on the plant capacity, the remanufacturing plant capacity. Then fixing of buyback prices. This is a very important, very difficult issue also. How do you fix? So we could found that many companies raise an issue that customer starts bargaining on buybacks, maybe because of unawareness of the sustainable issues and so on. So these are some of the issues which makes this return acquisition management a bit complex. Coming to the transportation issues, we have to think about how these used products needs to be transported from the sites, from the collection points to the manufacturing plants. So the first thing needs to be identified that who will be managing this whole chain, this logistic chain. Either it will be managed by the OEM, or it will be engaging third-party logistics providers, or there are third-party remanufacturers. So OEM is not doing remanufacturing. Instead, what they can do, they can support some small third-party remanufacturers in giving technology and other things. So it's independent remanufacturers. Then the responsibility of the service providers. So it talks about, like say, gathering. Sometimes what happens, suppose if you have a used products which is a very bulkier, so it's very difficult to carry the bulkier product to the site, the remanufacturing plant. So instead of carrying the whole used products, many companies, what they do, they disassemble, they sort it, they clean it at the collection points itself. So you have to decide now what kind of chain will be creating. Either you will be disassembling at the whole point, or you can carry only the good and used parts to the plant, or you carry the whole unit, or you carry the modules. So those things needs to be decided. So that's basically the responsibility you give to the service providers. Size and conditions of the returns. So that's a very important, because we have also found in case of industrial machinery, industrial equipments. Okay, so where the sizes are very large, with particularly in machine tools and in earth mover equipments, where it's very difficult to carry the whole used products to the sites. So that becomes a very big issues of transporting these bigger products basically. Then we require special methods of transports, handle and store them. In case of manufactured products, in case of new products, there are basically ways through which you can, established ways are there, established methods are there through which you can transport these new parts and components. But when you talk about used parts and components, we have to have some kind of special methods, because it's unknown. There's uncertainties are there. I don't know how big the used product will be, in what condition it is. So you have to have some kind of special methods in packaging, in handling these used products. So these are some of the issues which, when you talk about transportation, that needs to be addressed. Then in inventory, when you talk about, again, the same uncertainty factors will play, will create complexities in managing these inventories. So these are some of the issues like uncertain return flows, whether you will adopt a push or a pull policies. Talking about what pull and push policies, basically, what happens mostly in this remanufacturing business, you will find either it's an order-based kind of activities that goes on. When you say order-based means I am the customer, so I have a used product. I contact a remanufacturer and I tell him that you do the remanufacturing operations. I want it. You do all the disassembly, you clean it, everything, and return it back to me. Mostly, like say, big tires and other things for earth movers. So where the tires and everything are very costly, so they do this tire retreating. So there's a big operations. Even Volvo in Bangalore, so they are doing remanufacturing for the earth movers equipments, road rollers, dumpers, and so on. So that's basically a kind of policy. And there's another way of remanufacturing is that you collect the used products, you disassemble, you look for the use, the parts and components, and you may sell it to different customers. Okay. So based on that, you have to decide what kind of inventory policies you have to have. So shortages of inventory is a very common thing. You'll get it in, is a very common issue in this business. And then we have market demand. So just I was telling you, so whether you'll be remanufacturing the whole product or you'll go for a spare parts, or potential customers are basically the order base, or you are looking for a different customer segment. Okay. So these are some of the issues which makes this reverse logistic process very complex, okay, bit difficult. So how to deal these uncertainties, how to deal with this these issues. So we'll see, I have basically picked up some strategies, practical strategies, how they do it. Now talking about different reverse logistics models, generally in literature, broadly there are three types of reverse logistics models you'll find. And these are basically classified based on the roles of this OEM, how OEM is controlling this whole chain. So the first model will be where the OEM totally manages the whole chain. So they don't want to get cannibalized by their own product. So they want to retain their own technology with them. So for that, what they do, the OEMs particularly, they manage the whole supply chain like Xerox. So they are remanufacturing their own products. So if you see what the Xerox companies does, whenever they sell a product, they retain the information of their customers. So they give the service, they locate where their customers are. So when your products gets older, maybe 4 or 5 years, they may give an offer, okay, to exchange your products. So once they exchange, what they'll do, you sell it to the Xerox company. So they will take it back. So in India, they have a remanufacturing facility in UP where they take back all this, their own products. So they remanufacture it. And again, they sell it to the different customer segment, maybe in the local Xerox shops and other things, small offices. So that is one kind of reverse logistics model chains you find, where the OEM manages the total activity. The other type of logistics models you'll find where OEM basically focuses on only the remanufacturing operations, and the other non-core business of these companies like logistics and other activities like disassembly, cleaning, and other things, they outsource it to the third-party logistics providers. So that is the other models. So they can outsource, but what they do is that they also keep the control of the whole supply chain. Okay, it's not that they manage maybe independently, but they try to control it over in terms of creating more efficient and more effectiveness. So that is the reason maybe they are trying to control the whole chains. So many TPLs are like debt returns, FedEx, Astra. They are also engaged in this reverse logistics process for remanufacturing. And the third one is that where OEM doesn't play any role on this remanufacturing, and the whole remanufacturing activities is done by the totally an independent third-party remanufacturers. So that is So what these third-party remanufacturers becomes are competitors. So they become a competitor for the manufacturers. So that it happens, and mostly they try to cannibalize their products. So these are the three different models which exist basically. And these are basically common in automotive parts and components. Now, there are basically some strategies, broad strategies I just discuss, which try to build an efficient and effective reverse supply chain. And these strategies try to incorporate some of those uncertainty issues. Okay. One such strategy is devising logistic network designs, basically reverse logistics network design. So in literature, you'll find a lot of theoretical research has been done on designing these networks. So they basically focus on finding what should be the optimal number of collection facilities, where should be located, what should be the capacity of different facilities of different stakeholders in this whole chain. So these are, you'll find it mostly different models are there in literature. So apart from this, from my experience, I'll just tell you some other strategies which I found it very interesting. One is a strategy that is talking about a collaboration mechanism. Now, in this whole reverse supply chain, there are different stakeholders. You'll find stakeholders for collecting, somebody is transporting, somebody is disassembling, somebody is doing the inspection, somebody is cleaning. So there are different stakeholders in this whole chain. Now, it's very difficult for the OEM to manage whole of this chain. There are mostly these are basically done in a very small scale, and lot of third-party remanufacturers get involved in this business. Now, because remanufacturing has a different goal, it has a goal of sustainability. It has a goal of talking about social and economic environmental benefits. It's not only the money, it's not only the economics which is involved. There's involvement of environment, there's involvement of society, social benefits are there. So in such case, we try to develop different models like pricing mechanism and other things. We could not find a very good pricing mechanism of these remanufactured products. We could not get basically an equilibrium points where all the stakeholders can get a benefit out of it. So we could find that competitive models will not work in reverse supply chain models. Moreover, collaborative mechanism will help more in devising an efficient and effective reverse supply chain. So that is one very important findings I could get it from the studies. And there are different collaborative mechanisms which exist in literature. These are some of the collaborative mechanism we did a study. So this was basically like say between supplier and manufacturer, the collaboration purpose was on product design, how to design for remanufacturing and so on. Talking about manufacturer and customer. So we have different stakeholders in the whole chain and what should be the basic purpose basically behind this collaboration. So we could identify different collaborating partners, mostly 11 types of collaborative mechanism we could get it. And we have seen that these kind of mechanism basically creates a very effective and efficient supply chain. So that's basically a win-win kind of situations. So this is one broad strategy that can be adopted when you talk about reverse logistics and when you talk about remanufacturing. And one more interesting thing we could find, we talk about that's basically talking about industrial parks. So this study is basically carried out mostly in China. So in China, what they are doing, they have a concept called as urban mining. When you talk about urban mining, what they find that these mostly the cities, urban agglomerations, if you see, they have, or when you talk about mining, basically, okay, it's basically we talk about that we extract material from the earth as a raw material, and then we get the maybe different minerals. The concept of urban mining is that it's not the mines which gives you the resources, the raw materials only, but the cities and urban agglomerations, they are also a very big source. There's a very big source of used products. And if you think about these used products, it is in million tons each year. So what China has done in their plan, they have thought about setting up of industrial parks. And these industrial parks are basically circular economy oriented industrial parks. So they are basically located near the vicinity of these urban agglomerations. So what they do, if you set up an industrial park, and in an industrial park, you give facilities to all the players. There are disassemblers, there are cleaners, there are inspectors, there are research centers, there are companies which are remanufacturing automotive parts, there are companies who are recycling metals. So in the same umbrella, maybe within a few kilometers, in that same region, you are having all these industries at one place. So once you set up all the companies, all these, if you facilitate all these recyclers, all these remanufacturers in a one common area, then what happens? These uncertainties of getting materials become nullified, almost nullified, isn't it? So that's the interesting part when you talk about these industrial parks. And China, in fact, they have started 30 urban mining demonstration bases. And these was basically built up by this Chinese government with some objectives like recycling of this urban mine. So when they saw urban mine, it's basically the urban waste, and which is get there from its local areas. So there's an example, like one such example I'm just giving you, which has been set up in Milo Industrial Park. So this is an urban mining base of Milo Industrial Park. Some figures which will tell you how beneficial it is. So it was demonstration for setting up of this CEO-oriented development and mining. So this industrial park was been set up to boost a long history of waste goods recovery. So there's a large group of waste pickers and a national-wide purchase network. So at present, this city is housed more than 200 resource recovery enterprises. They have 3,000 business operators and more than 5,000 purchase outlets. And in this industrial parks, almost they're giving an employment of 1 lakh employees. So you can see how big and how efficient it is. So you are under a single umbrella. So they are having the whole resource so there's no basic requirement of a reverse logistics. Everything is available in that umbrella there. So that's a benefit of this. And its annual capacity has almost surpassed 1.1 million tons. Okay, so such 30, I think 28 such industrial parks are operational in China. So what is, you can imagine how huge amount of remanufacturing business they are doing. So it's not only remanufacturing, recycling and other things also. So broadly, I could identify some of these strategies which can help and vary. So we should also think about it that direction. So just to summarize, I will give some concluding remarks. What I could find in Indian situations, mostly these remanufacturing companies, basically they operate in very small scales, and their annual turnover will be around 1 to 10 crores, and a very small number of employees work there. But when you talk about the different activities and you sum up them, it becomes a very big business. So under such setups, you can think of setting up circular economy oriented industrial parks. The other thing I got it from the mostly from the Indian remanufacturers, that most of these companies, when I say companies, means Indian companies, they abide by all the government laws related to environmental protection acts and the other laws which is existing in India. But the hard truth of these companies, what they say, that they are not been given a chance to participate in governmental contracts. So that's an interesting thing I could find, because of the fact they are not allowed to sell remanufactured products. So a lot of literacy is required there. You have to educate, educations and other things needs to be changed here. So that's a one interesting thing I could find. So social awareness is a very important thing that needs to be implemented in India. So to make these companies a part of the mainstream business. There are a lot of remanufacturers in India which operate as a highly disorganized way. So that needs to be thought about. So because we are working on a platforms like this, remanufacturing workshops, and so I think this is the first one, to my knowledge, why NIFT has organized such a good workshop on remanufacturing. So that's why I just thought about just pointing out some of these remarks. These are some of the companies which are there in India. Like say, this is a Volvo, which is doing, first one shows the Volvo manufacturing plant at Bangalore in Pinia. These are some other companies which do industrial machines. Even in India, I could find there are recycling of bags, jute bags. These are bags are been also recycled. Cotton and cloth is been also been recycled. So you can think how extent we are also doing this business. But the other part is that it's basically a disorganized sector. Okay, so that's from my side. Thank you, everyone.
Thank you very much, sir. To insight the reverse supply chain prospects and challenges, you have also clearly briefed the key reason behind the unpopularity of remanufacturing business in India. Thank you very much, sir. So we have questions. So I request to participants, if you have, you can write in the question answer box, or you can raise your hand. So, sir, we have one question which is asked by Rajnikant Chandan. It's in the question answer box.
So, talking about health checkup of disassembled parts. Yes, really, it's a very big, difficult task of finding out the remaining life of used products. Okay. In fact, there are some methods which are being used. Maybe you will be listening in the tomorrow's lectures when they talk about technology and other things. So I could found one such method which is through vibration analysis, where they do have signature analysis kind of methods are there. So in signature analysis, what they do, they have a signature of the original products, and then they try to match with the older ones. So, so this is one such method that is basically used. In fact, there are other ways like reliability analysis, which is still going on. So that is how, but still it's a very difficult task, I agree, to find out the remaining life of used products.
I think no more question is there, sir.
Sorry, Professor Mondal, I have a question for you from Sweden.
Yeah, Rick.
Hello. Nice presentation. I was wondering, in your examples, do you have any large OEMs doing remanufacturing in India, as you know, besides Volvo?
No, still I could not get. Cummins is also, there's one industry. Cummins is also doing engine remanufacturing. So there's a plant in Mumbai, near Mumbai in Pune.
Yeah.
So they are doing this engine remanufacturing.
Yeah. I think Tetra Pak also have in Pune as well. I think.
Yeah.
I'm
Yeah.
not sure. Okay. Thank you very much.
Mostly I could find these two companies who are doing really set up a really a good remanufacturing site. So I had the opportunity to visit their plant. So, so Eric, it's a very long time we are meeting, I think.
Yeah.
We met it maybe in Amsterdam.
I wish I could go to India at some point in my life to see remanufacturing.
Yeah, definitely. So in fact, Eric is doing a very good job. He has a very good team on working on remanufacturing. I think EV batteries and other things we are working. Yeah, so that's a very big opportunities in India, because at some point of time we have to switch over to EV vehicles. So what to do with this old huge this fossil fuels run vehicles that has to be converted. So still, I think many companies are doing on this work. Many companies they have started doing in India, but I don't have much idea what they're doing. But I got some information that there are many companies which are converting these fossil fuel vehicles to EV vehicles. They're thinking of some technology and other things. Okay. So
yes, in Sweden the electricity price is really high now, so people are starting to use electric vehicle batteries for storing electricity.
Yeah.
Thank you very much, sir.
Okay.
So now we will end this session with the vote of thanks to our honorable speaker, Professor Sandeep Mandal sir. It's my privilege to present a vote of thanks on behalf of our organizing committee. I would like to express my gratitude to honorable speaker, Professor Sandeep Mandal sir, for his gracious presence. Thank you, sir, for this enlightening talk on reverse supply chain prospects and challenges. So definitely this will trigger to the new domain for the faculty, for the researchers and the attendees available here. Thank you very much, sir, from our organizing committee.
Thank you,
Professor Eric sir and Sandeep Mandal sir, both. And before ending these sessions, for this attendee, we have some announcement that we have tomorrow, the another sessions that is in remanufacturing technology. We have 7 sessions. Before noon, it's 4 sessions we have. It will be started from 10:30. Professor Mustafizur Rahman sir will give the talk on this advanced machining techniques in remanufacturing. And then further, the second session will start from the 3 to 6. With these words, I announce the end of the sessions. Thank you very much to all the honorable speakers and the attendees. Thank you very much.
Thank you.
Thank you.
Thank you.